Stream is starting, the Captain Coder at the helm. Bean water is ready. Today we will learn a lot. He loves the questions, he loves to sing. Join our Discord and follow him.
Good morning, good afternoon, good evening to you, wherever you happen to be in the world. I hope you're having a beautiful day. Captain Coder here on this beautiful Tuesday morning, and we got the whole crew here with us. I'm so excited that all of you beautiful people are here with me. I gotta say thank you to Spoof for being the actual first. Spoof was first, exclamation point. You gotta do exclamation point first to get that first. You were so close. You're so close, Spoof. Welcome back. It's so nice to have you here, my friend. Kavadratisk. I am also very glad to have you here. Sounds like you're having a little bit of trouble with part 2, which probably doesn't bode well for me. But hopefully, we'll see if I can get part 1 done. Then we can take a look at part 2. Maybe you can draw in some inspiration at that point. Clayman, how's it going, buddy? Welcome back. Clayman, thank you for getting that exclamation point first in, collecting those points. Incredible human being over there. And Sijian, nice to have you back, my friend. Sijian, just to reply to you, I want to get that outro song too. Folks, if you guys don't know Sijian, incredible human being, incredible person. We love Sijian. Sijian made that intro song for us. I need to update your text here to say you're also my 2,000th follower. Sijian was my 1,000th follower. Also, unfollowed just to be 2,000th, which, you know, my friend, beautiful. I love it. But I think let me correct me if I'm wrong. I believe Sijian is the one who, I know Sijian did it for sure. Sijian made that theme song. And then we put some videos on top of it. It's so much fun. Sijian, I do want to get an outro. There's an outro song too Sijian gave to me. I just haven't. Look, Sijian, will you forgive me? I've been busy, my friend. I've been busy in Advent of Code. It's not made me any less busy. It's just been so much fun doing Advent of Code here. Dramulks, how you doing, buddy? Dramulks, it's nice to see you. It's nice to have you here. How have you been? How is it back? How does it feel being back in Unity, my friend? Do you miss the C++? Do you miss being in Unreal Engine? I'm just curious. Is there anything you miss, Dramulks? Is there anything that you miss about Unreal Engine? I'm just curious. I haven't used Unreal Engine. I kind of want to give it a go. I know Clayman, you gave it a go at one point too. What were your thoughts on it? And Kylo, welcome back. We got Kylo here today. Kylo, I'm so glad you're with us on this beautiful Tuesday morning for me. Whatever time it happens to be for you, I hope you're having a beautiful day, folks. And then Nineberry, welcome back. Thank you for submitting your solution. We're gonna take a look at that in a little bit, but we gotta look at day 12. What are we doing today, folks? What is happening? We are working on Advent of Code day 12. Day 12. Let me go and get this pin going up here. Advent Code of day 12. We're with Hot Springs. We're gonna read through that. If you're not familiar with it, Advent of Code is an advent calendar of small programming puzzles for a variety of skill sets and skill levels. They start easy and they start easier and get harder as time goes on. Nick, welcome back. Spoof says, I would say today was the hardest day so far. I think harder than day 10. Ooh. You guys trying to psych me out over here. We're gonna see how we do. But we're taking a look at it. Nick, I hope you're having a beautiful day, my friend. Good morning. Good time zone to you, my friend. All right, let's take a look at Hot Springs day 12 here. You're gonna give up on getting it under 1 millisecond. You can always come back or look at what other people have done to see what types of optimizations they have. I don't know if it's technically possible to get every puzzle under 1 millisecond. I don't know if that's true or not. Certainly every puzzle under like 500 milliseconds seems really doable. 1 millisecond is like an extreme challenge. Hi Tintandon, welcome back to the stream. How you doing, my friend? I'm doing absolutely wonderful. We're here on day 12. Ninebear says, I have 120 milliseconds. I'm very happy with that. Gotcha. When you're using a fast language, yeah, most, these are all, not all. Typically these puzzles, you just need to have you got to use the correct algorithm, a high speed, to make sure you have like an efficient algorithm, not the best algorithm, an efficient algorithm. Let's take a look here. Hi, Tintandan. I'm so excited you're here, my friend. Welcome back. I'm so glad to have you again here in the stream, here at Captain Coders Academy, where we're doing Advent of Code Day 12, Hot Springs. Let's get that voice going. You finally reached the hot springs. You can see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stops you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry, common mistake. This is actually the onsen. What's an onsen?
Whoa.
The Japanese hot springs. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead. This way! The DevDad holy cannoli with a raid! DevDad, thank you for raiding. Thank you for raiding me. Enjoy your tater tot, my friend. Enjoy that slice of pizza. I'd love to see those shirts side by side, folks. If you guys don't know the DevDad, he is an absolute trifecta of a human being, software developer, streamer, father, building a productivity app called Embedder in his spare time, and you can watch it all unfold over there on a stream. Check it out. Be sure to give him a follow. Incredible human, one of my favorite places to be. Thank you again so much for the raid, DevDad. We are doing Advent of Code Day 12, folks. Advent of Code Day 12. Topologist, welcome back to the stream. It's nice to have you here, my friend. It's nice to have you here. We are doing Day 12 Hot Springs. I'm going to read the puzzle over again, so anyone just coming in will get it. But the Advent of Code, let's do an AOC here. The Advent of Code is a series of puzzles, if you're not familiar with it, that come out in December. Our good friend Eric Wastel, I don't know how to pronounce it, puts together these puzzles for us every year. Incredible human being, and we're going through and solving them. We're having a good old time. This is, we wake up and we code. All right, here we go. You finally reached the hot springs. You can see steam rising from secluded areas attached to the primary ornate building. As you turn to enter, the researcher stopped you. Wait, I thought you were looking for the hot springs, weren't you? You indicate that this definitely looks like hot springs to you. Oh, sorry. Common mistake. This is actually the onsen. The hot springs are next door. You look in the direction the researcher is pointing and suddenly notice the massive metal helixes towering overhead. This way! It only takes you a few more steps to reach the main gate of the massive, fenced-off area containing the springs. You go through the gate and into a small administrative building. Hello! What brings you to the hot springs today? Sorry, they're not very hot right now. We're having a lava shortage at the moment. You ask about the missing machine parts for Desert Island. Oh, all the gear island is currently off. Nothing is being manufactured at the moment, not until we get more lava to heat our forges. And our springs, the springs aren't very springy unless they're hot. That's hilarious. I just got this joke. The hot springs are springs that they need to be hot so that they spring. They need to be warm. They're the hot springs, not an actual hot spring. Oh my goodness. That is such a good joke. I just got it. It clicked. All right, Say, could you go up there and see why lava stopped flowing? The springs are too cold for normal operation, but we should be able to find one spring enough to launch you up there. That's hilarious. Dasa Murray, welcome. Da Samurai, welcome to the stream. Nice to have you here a bit. That's hilarious. There's just one problem. Many of the springs have fallen into disrepair, so they're not actually sure which springs would even be safe to use. Worse yet, their condition records of which springs are damaged are also damaged. You'll need to help them repair the damaged records. In the giant field just outside, the springs are arranged into rows. For each row, the condition records show every spring and whether it's operational, a dot, or damaged, a hash. This is the part of the condition records that is itself damaged. For some springs, it is simply unknown, whether the spring is operational or damaged. Smab, I love the jokes. I love the puns. They're hilarious. This is such a good joke. That's like super programmer humor there. I love it. Maybe it's not programmer humor. It's just good old humor, but I love it either way. However, the engineer that produced the condition record also duplicated some of this information in a different format. After the list of springs for a given row, the size of each contiguous group of damaged springs is listed in the order those groups appear in the row. This list always accounts for every damaged spring, and each number is the entire size of its contiguous group. That is, groups are always separated by at least one operational spring. 4 hashes would always be 4, never 2, 2. So condition records with no unknown spring conditions might look like this. I didn't quite understand that, but let's look at the example, see if I can figure it out. 1, 1, 3. Okay, so we have one group of 1, one group of 1, and then a group of 3 separated by dots. 1, 1, 3 could also look like this. 1, 3, 1, 6. Okay, so we have these dots, separate them out. So we're either, it's like a binary thing on the left side, and then it's some information on how they're grouped. Smap says, by the way, I have not finished part 2 yet, and the rest of my week is really busy, so don't know if I'll even get to part 1 for them. Smab, no worries, my friend. Other people have said part 2 is tricky, so I'm a little nervous. We're gonna see if we can do it though today. We're gonna see if we can use the old noodle. To do something clever. But we'll find out. I don't know if it's true. If I missed something in chat too, please let me know. GNU parallel, it's spawning multiple processes. Okay, just wanted to catch up there. All right, however, the condition records are partially damaged. Some of the springs of the conditions are actually unknown. Question marks. Okay, so we have question marks and hashes and dots. Dots and hashes are known information. Question marks can be a hash or a dot, and we need to use this information over on the right side to determine which ones are hashes and which ones are dots. And potentially, you know, the combination of it. Alexito, the burrito, you're so tasty, the burrito, welcome back. Alexito, the burrito, thank you for being here, my friend. Happy Tuesday to you. I hope you're having a beautiful day. Okay. So a little bit of a hint there for part 2. So that's okay. I guess I should probably thanks for being first, Moonness. So my guess here is a little bit of a hint for part 2. I'm okay with hints. Dynamic programming is needed in part 2. It sounds like. We'll try not to talk about part 2 until I get there. It's okay. Doing part 1. All right, we're gonna turn this on. Doing part 1. Let me add a little text in here. Try not to spoil part 2. All right. Part 1, I'm okay with people doing a little bit of talking about how part 1 works, but we're gonna try not to spoil part 2 because I just haven't seen what the puzzle is for that one yet. Moonness, I'm glad you're here, my friend. Folks, if you guys don't know Moonness, incredible streamer, incredible dank developer, incredible game developer. His full-time job is working as a game developer. Streams on Twitch sometimes. Go check him out. Yeah, Spoofs, DP is, well, it's a little, you are caching. It's the way you build up your solution in dynamic program. It's the way you build up that cache that is important. All right. Equipped with this information, it is your job to figure out, folks, see that little heart? Give Moonness some love. Don't you want to watch someone make a game? Don't you want to watch someone make a game? Moonness. Go watch Moonness make a game, folks. All right. Sorry, I got distracted. Let's focus here. So I believe it doesn't really matter if you go top to bottom or bottom up. Top down is usually called memoization, and you do it recursively. Dynamic programming is usually bottom up. I know nothing about that, which is presumably why none of my techniques are working. Gotcha. It's funny, it's not as funny seeing a game being made as it is seeing your torment. It's true. I will say, watching me torment, Spoof said, Spoof, if you switch to dynamic programming, dynamic programming is almost always faster than memoization. Just so you know, since you're talking about you're trying to get yours faster, DP is almost always faster than memoization, depending on how it's implemented, of course, because you have overhead when you're doing recursion. I'm looking at this and I'm already going like, okay, I'm going to do a recursive solution on mine. The recursive solution just seems straightforward to me. Spoof, I can be wrong though. I might be wrong. I think I'm gonna preface that with I think. Sweet Red still part one. It is if you do perfect implementation. Gotcha. You have courses for Unity just out of curiosity. Tricky, so tricky. I don't have too many. The word course is a strong word. I have a couple projects. I don't know if I have commands for it. Let's see here. I got character creator. This is a project I have my students do in 2D Unity. So I have my students do this project in 2D Unity. There's no coding in this one. This is all about learning the interface and how to do Canvas stuff. So we do have this one. And they're free. They're open source projects. So when I say courses, I want to be, you don't have to pay or anything like that. I also, over on YouTube, I do have a playlist for making a platformer. So if you want to go over to YouTube, sorry folks, slight distraction. Let's do it. We have a 2D platformer in Unity over on the YouTube channel. And then we have Unity demos and crazy marble stuff. So I have a few little Unity things. I also have Adventure Quests. Adventure Quest is another project that you can do in Unity, which is like you learn about test-driven development in Unity. All right, back to our regularly scheduled program. Tricky, so tricky. Also join the Discord. We got lots of people there willing to help you out, chat with you, and help you stay on track on learning to make games and learning to code. All right, let's see here. Equipped with this information, it's your job to figure out how many different arrangements of operational and broken springs fit the given criteria in each row. All right, so there's gonna be some set of permutations of this. And like my initial thoughts, we just pull out things from the beginning and we say, okay, if it's a question mark, we turn it on or off. And if it's a hash, we subtract a 1 from this. And so we can like recursively go and suck information out here. The second line is more interesting here. This one's hard because we have different permutation of it. This is where recursion's nice because it automatically builds this tree up for you. So that's what we're gonna look at. The thing where dynamic programming comes in really nice. After we've done these two things, the solution for this part, the solution for the remaining part here is gonna be the same regardless of how we've determined these two. So there's gonna be two different solutions for this first part. And then we can solve this second part here. And so if you use caching, you can cache the result of this thing and you know it when you propagate back up to here. So that's sort of, you have to set it up right to be able to do this. Let me keep reading, just make sure there's no caveats. I find the memoization recursive usually is easier for me to do than dynamic programming, but that's just because I haven't practiced dynamic programming enough here. Let's see, the last question mark always must be broken to satisfy the final contiguous group. And each question mark must hide exactly one of the two broken springs. Neither question marks could both broken springs, or they would form a single contiguous group of two. That would true. The numbers afterward would be 2, 3, since each spring question mark can either be this or that. There are 4 possible arrangements of strings. The last line is actually consistent with 10 different arrangements because the first number, they give us some great sample inputs to test with here, which is nice. All the different arrangements. We actually don't care about the arrangements themselves, I don't think. I think we mostly care about counting them because this is an advent of code puzzle, right? In this example, the number of possible arrangements for each row is the following. 1 arrangement, 4, 1, 1, 4, 10, and then we're gonna sum them up or produces a total of 21 arrangements. What is the sum of those counts? Okay, how many inputs do we have? So really, if our inputs are super long, then that's where we're going to need help. Oh, these aren't even that long of inputs. Huh. All right, so these inputs aren't that long. We have a lot of them, but the inputs are relatively short. Relatively short. There's not even that. There's quite a few of them. There's like what? A few hundred, maybe 1,000. The inputs are really short though. Okay, let's do it. Let's do it. Tricky, so tricky, tricky, so tricky. You're tricking me today with the follow. Tricky. So tricky, thank you for following me. Tricky, so tricky, thank you for the follow. Welcome aboard. Welcome to Captain Coders Academy. Happy to have you here. Hi, Tidden says, that's why dynamic programming is very difficult for this question, because you can have something like ... question ... question question hash, which would then result in 5 runs rather than 4. I think from my mental calculation. Dynamic programming, the way you set it up, it looks like you could have accidental duplicates. I'm going to do it recursively because the recursive solution feels really straightforward to me. Let's set up our project here. .net. People, don't get mad. I didn't write a script to do this yet. I didn't write a script to do this. Make their tests. .net. So in your dynamic solution, you just got to make sure you don't produce duplicates and you'll probably be okay. .net, new xunit, .net. Let's see if we can spell shouldly right today. We spelt it wrong last night. Add package. Should. There's an L in shouldly. Version 4.2.1. Huh? Oh, baby, we done did it. We done did it. All right, we forgot to make our implementation. Make their implementation. Man, we're gonna make sure we sanitize our input properly this time too. We're gonna make sure we sanitize our input properly. .net new. .net new console. I'll do it with the console project so I can do some stuff with it. cd .net sln add implementation .net sln add tests. Let's go into our test folder and .net, add our implementation, add reference. Okay. Code here. I might do it in DPA way later, but it seems kind of tough because you would need to deal with partially broken up blocks. Yeah, I always, not always. There are some puzzles where the recursive memoization is just awkward, but usually I find doing recursion stuff, I think it's just because my brain really likes functional programming, and recursion, the recursive solutions usually make a lot of sense to me. All right, so we got our tests here. Let's do a commit, git, add it, git status, make sure we're not doing anything. Commit -m. Ooh, I forgot to commit some stuff. Be a chore initialize day 12. We're on day 12 parts. That's crazy. Day 12, initialize day 12. There's no part here. I forgot to add something here. Git commit -m chore. Forgot to commit. I don't know exactly what's going on here. Day 11 it looks like. Day 8, day 9, day 11 misses. Push that up there. All right, let's come back into day 12. Let's set up our test here. I'm going to call this day 12 tests. Rename this day 12 tests. Test sample input like this. And sample input. This is the sample input. Really, we're gonna do this first. We're gonna do test sample input. Sample, and I'm gonna change my life to this thing. So I don't break everything like I did last time. String array. This is sample public static read only string array sample input is gonna be this thing. Not trim. Pull this up. We got another raid hex tree. Hex tree. Oh, hex tree. Thank you for raiding me today. We've got hex tree. Oh, hex tree. Welcome to the Academy. Raiders, welcome aboard. So nice to have you here. Hextree, thank you so much for the raid. Bad Cop, welcome back. Someone told me, Bad Cop, someone told me you've been doing these in Bash. Is that true? But Hextree, how do we do, folks? Also, if you want to watch an incredible programmer hack their way through an advent of code puzzles, attention all lurkers. Look, you see that little heart? Look, lurkers, right here. You gotta click it, click that button, because you don't want to miss out on Hextree, folks. Lurkers, click that button. Give them some love. Do it. All right, folks, do it. I managed in the end after 3 hours. Gotcha. People have been making me feel a little bit nervous about part 2. We're gonna find out though. Backup says it's true. I plead guilty. It's okay. There's nothing wrong with bashing your way. Through these puzzles. Took me 6 hours in Bash. I can imagine being a little bit tricky. I teach a class sometimes. All right, we're gonna do this. Replace line endings, and then trim. No, not trim. No, hang on. It's gonna be a trim, then replace line endings, then split on environment.new line. Okay. It's gonna be our inputs. It's gonna be our sample, our sippity sample inputs. Took you 6 hours. I teach a class at my school sometimes called Command Line Kung Fu. I call it Command Line Kung Fu, and it's actually a Bash programming class. But we do all kinds of cool stuff in there. Dammer. God dammer. Oh boy, what a name. Have you met Goddammer? They have got the damn today, you know, Goddammer. Yes, can I say that on stream? What we do on my stream is command line war crimes. It happens. You'd love to see those cool little tricks though. Those cool little tricks are some of my favorites. I already hate this. I'm gonna go back to just a basic string here. And I don't like what I'm doing here, but we will do dot trim like that. We'll do the replace line endings in the actual processing part here. Okay. Thanks for the lulz, Nick. Thanks for the rolling, the laughing rolls. Goddamn, I hope you're having a beautiful day. Oh, what a name. What a fun name. Here we go. Den solution invokes image magic at the end. Did you use the flood fill? You used a flood fill for that? I did flood fill too, but I expanded the image. That's hilarious. Oh my god. You did a flood fill, then you counted like pixel colors. That's amazing. I love that so much. What a cool solution. All right, so this is gonna be day 12.part. We gotta make a day 12 file first. New day 12 public class day 12 like this. And we're gonna create a method public static long part 1 string input like this. We're gonna return 0 for now, and then we can say that let's get Shoodly in here. Shoodly, did you know Shoodly has an L? Look, folks, right there, evidence, proof. Shoodly has 2 L's. There we go. Nothing compared to when the captain said, "Come on, I'm so sorry. I'm sorry, my friend, folks, for having to suffer through. All of my songs. 50 bonus points. We got into a big argument on my stream about whether or not TDD exists, it even exists. I think something that people don't realize is test-driven development doesn't help you write code. It helps you refactor code. So there's like a difference. If all you want to do is build something as quickly as possible, don't do test-driven development. If you want to build something that you know you're going to have to modify later, test-driven development can be useful. I mostly do hope-driven development over here, and I just hope and pray things are going to work. And then when they don't, I start writing a little test. I write a little test when things fail. But look, to each their own. It's kind of like I do meme-driven development. Meme-driven development. That's truly the only way to develop, right? Truly the only way to develop. We're gonna say this should be 21. We should be 21 here. All right. What I really want to do though, we're gonna write a method in here. Here's the real twist. Who tests the test? It's right. It's the whole issue with the Watchman. Who tests the test? If you can get away with it, Nineberry, the users, ChatGPT will test your test for you. That's the real answer. Oh, what was I gonna say? Who tests the tests? If you're using the best languages, ChatGPT writes the test for you. I'm a big fan of hope-driven development myself. Cereal bars. I'm a big fan of your name. I'm a big fan of your name because I need 77 cereal bars. I love me some good cereal. All right, we're gonna write a method: public static. I can't think of the word I'm looking for. Long, count possibilities, count. What are we doing here? We're count springs or process spring, string input like this. Here's really what I want to do for my test just to make my life better me. My life better me, folks. Theory. We're gonna do a theory here. We're gonna do a public void test process springs test process spring. It's several springs, not just one spring. It's springs. All right, and it's gonna take in this string line like this, and then we're gonna do line like this, and then we have a long result expected like this. And so we can just do a bunch of these. Day 12 process springs line dot should be expected like this, and we can do an inline data where we take each one of the lines. Line 0. I can do it this way. All right, so we're gonna do this once for each of our inputs. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this is just, look, I wouldn't even call this test-driven development. I call this specifically input validation tests. Input validation tests is all we're doing here. All right, just to give myself confidence that we got it. One more, not one more. There's three more. One more time. Nope. Two more times. Look, my mouth knows how to do the thing. All right. And then there was one here. All right. And then in our sample input, we had, hang on, I can find it. I know how to tab. I know how to tab this. Do I even tab? All right. We have 1, 4, 1, 1, 4, 1, 4, 1, 1, 4, 10. 1, 4, 1, 1, 4, 10. 1, 1, 4, 10. Okay. All right, folks. Let me catch up on the chat. Travel the world. How you doing? It's good morning, my friend. How you doing? I'm doing absolutely wonderful. It is 5:35 a.m. here, and we're having a beautiful morning. Kavaja says, ensure that the captain suffers as much as he deserves. It's okay. Look, I deserve to suffer as much as the next person, and that's okay. I'm gonna steal that for my bot. I missed something. Bad cop. What do you have for your bot? Oh, the queue. Or what? I missed something. What are post links? Stealing my queue command. Gotcha. Yeah, it's really helpful when chat starts. Look, I had to introduce that once I had. Once there's too much chat going on, especially if I'm trying to solve a puzzle, it gets crazy. All right, let's just make sure that all of our tests fail, because if they don't, we've done something terribly wrong. And then really, we're gonna start by implementing this thing, which is just sort of like a recursive call here. Cop that's stealing literally a bad cop. Look. It's okay. It's not stealing, it's borrowing. No. Bad Cop was inspired by. Inspiration strikes. It's not stealing, it's inspiration. It's inspiration. All right, so given a line of input, we kind of have two chunks of the input. So I'm gonna write the helper function down here, public static long process springs. This one's gonna take the lefts and then right like this. And it's just gonna have we split on a space. So this is literally just gonna be I guess I should do it down here. Input.split on space, and then we return string parts, and then we return process springs on part 0 and part 1. So this is going to get our input. So we have the reason I'm leaving it as strings, it's going to be easier for me to memoize. It'll be easier for me to memoize this thing if I have my left and right as strings. If I parse them into lists or something, it'll be harder for me. It'll be harder for me. Yeah. All right, here we go. Thank you for solutions. Thank you for your solutions. The whole joke it wrote itself. Sorry, Clayman says it's okay. You don't have to apologize for being hilarious, Clayman. You don't have to apologize for being hilarious. So let me create a cache. So for people who haven't seen this technique before, let me do it without a cache first. I'm gonna do it without a cache first. It'll be easier to debug. Is that true? It'll be easier to debug because I might change this implementation a little bit. We want to, let me think here. Our input is gonna look something like this. Okay. And if the, I need something slightly different. I need something slightly different. Kamadra Tisk, that's exactly what we're doing today. We're day 12. So day 12 here. What I want to do is I need a base case for this recursion. I want to say if left is empty. If we have the empty string, then we either have if we're the empty string and the right side, and we've exhausted all of this, so the right side is just like the number 0 essentially, then we're gonna return 0. McNets, welcome back to the stream. McNets, how are you, my friend? McNets, it's going incredibly well. We're on day 12 here. We're having fun. I think I have an idea for a solution. Maybe I should write it out by hand and work through all the different possibilities. That's with the possibilities like that. The possibilities here. But if our left is this and right, essentially it is this. We can't do this. You guys, look, I've been writing too much Python. Num is, we need a num here, is 0. Num is 0. So it's kind of like, I want to know what the first number in this thing is. Something like that. I got to think this through a little bit better. My parts, 1 here, I need to essentially split this. I want to be able to memoize it is the issue. What is the what is the forbidden language? I don't know. What is the forbidden language? Lance, welcome back to the stream. How you doing, my friend? I hope you've been well. How's your game coming along? Did you get your character sheets for your space game working? Just curious, just out of curiosity. It's a curiosity. All right, so we have this. I need to I want to say like this is our front number here. Front number here. And part of me wants to start it at 0. And when we could also start it as we want to pull off. I gotta think this through. Build a list splitting. Make nets. I want to be able to memorize this, and if I make this a list, I can't memorize it easily. So I just want to pull one number off the front of this at a time so I can write a memoization. If I turn it into a list, the memoization becomes trickier, and the recursion becomes trickier because now I have a list where I'm not doing stuff. 100 acres memoization is the process. I could use a linked list. If I did a linked list, like an immutable linked list, that would work as well. 100 acres, it's caching. Memoization is caching. It says, if I call this method with the exact same arguments twice, don't do the calculation a second time. Save that calculation and return it. Ginny Louise Brown, what a great name, Ginny Louise Brown. I would like to welcome you today to the stream. Yes, Ginny, welcome aboard. Welcome to the stream. Happy to have you here, Ginny. Welcome aboard. Welcome to the Academy. Thank you so much for the follow. Okay, so I think I'm just gonna have int num string right. Let me pull this out here. Parts of 1 dot index of. Am I doing something really dumb here? Index of this. I want everything before that. Maybe so the cheap way to do it would be a splits on comma dot select int dot parse dot first. So I could do this. Int num is the first one, and then all right, let's do this. Int dot parse nums, and then we will do nums of 0, and I'm just gonna combine these back together stupidly. Nums of 1 dot dot, and then I'm gonna do a string dot join comma. This is really dumb, but that's what I'm doing. Can split to only return 2 parts. Nineberry, is there an easy way to do it? Split input 2. Split. Hang on. There's different. Could you cache them as a hash? That's the plan. That's exactly why I've kept it as this. That's why I've kept them as strings, specifically to make that a little bit easier. Split. Oh, split has int count. Okay. Int count. I didn't know that we could do this. Beautiful. Thank you so much for that information. All right, so we're gonna split comma 2, string options, remove entries, just in case. Okay. So this would be string array more parts. This is nums like this, and then we'll do nums of 0, nums of 1, and this one's going to be an int.parse. All right, so we pull that first number off there like this. Yeah. So I'm doing it specifically as strings and an int here, so that way I can actually cache this thing more easily. What are you complaining about? the syntax error. Semicolon. Okay. Nums of 1. Nums link could still be 1 at the end. It's still a string though. It's still a string and I'm okay with that. I still want it to be a string. If it's a 1, oh, you're saying I could do a split and it could still be 1 at the end. Oh my goodness. String rest is equal to nums.length is 1 string.empty, otherwise nums of 1. Thank you. Rest. Okay. This is dumb. This is stupid. There's got to be a better way to do this, but this is what we're going with. All right. So let me think about this. We're going to say if left is the empty string, this means that we have reached the end of the input, and the right is also empty, and the number is 0. That means this is a valid configuration. You mean nums of 0 if... No, I don't. No, I don't. I don't mean nums of 0 if length is 1. It's the empty string. I'm pulling the element off. So if I have this 1, 2, if I have 1, 2, 1 is the number I'm doing, and the rest of my string is 2, like this. If my number is 2, the number I'm doing is 2, and the rest of my string is empty. So this is the current value I'm processing. You could do equal 0. I think it's valid. I actually should do equal 0 because it's an integer. This is the better way to do it. Nick, this is probably the better way to do it here. But we're gonna say if we've reached the end of my spring input and there's no more configurations at the end, and this number is exactly 0. And this number is 0. I gotta think this through. That means that this configuration is valid. Is that right? I'm at the end of my input, and I'm gonna call this remaining springs. This is, I don't know what to call this num here, but this represents the number of the group, the number of springs that have to be in this group. Okay. Springs is, we have a valid configuration. Okay. Balint, welcome back to the stream. Welcome back, my friend. Happy to have you here. Also, I don't know if I said hello to Travel the World. I saw your message. I acknowledged it, but I don't know if I said hello to you, Travel the World. You're one of my favorites. You're one of my favorites. You're all my favorites. But Travel the World, you got a little extra space reserved for you just in my heart there. Okay. What is the other case is, all right. We need to do this because we have an internal condition. If springs is empty, this is our base case. If the spring is empty, we want to say if remaining is also empty and num is 0, return 1. Else return 0. So this case here, we have found a valid configuration. If we're at the end, so if the springs is empty, remaining is empty, else if and this is, so if springs is empty, hang on, if springs is empty, any other case should be 0, right? Because if the springs is empty, but we have more configurations after this one, if we have more configurations after this one, we fail. That means it's not valid. If we have more numbers and springs is empty, we're also not valid. There are some consisting only of question marks. It's evil. This is where I think the memoization is going to be helpful here. All right. So I think that makes sense here. Let's think through the case here. Thindle, welcome back, my friend. So I think this is our main base case. We have another base case that says if num is 0 and remaining is empty. Okay. If we have no more configurations to find, but we have more springs, here. I feel like I need to draw some of this out. So I'm thinking of this as a unit. This is sort of a unit. Thindle, how have you been, my friend? It's so nice to have you back. Welcome back, Thindle. I hope you smile, my friend. I hope you're smiling. For example, you can have more springs as long as they're not broken. Yeah, so I'm thinking about this part here. We want to find if there are any more. This is saying broken in next group might be a better. I hate that, I'm gonna just call it broken. This is like the number that must be broken in this group. If broken is 0 and we have nothing left, if in a room, it springs dot contains a hash. If springs dot contains a hash, return 0. This can't possibly be a valid configuration. Concat contains. Else return 1. We have a valid, the rest of this is a valid configuration. If we have no more, if we're all dots here, this is a valid configuration. All right, so if we have examined all of the springs and there are no remaining broken springs, this is a valid configuration. Otherwise, it is invalid. And then here we have, if we have no more broken springs in the config, and there are still broken springs in the input, this is not a valid configuration. Otherwise, it is. Okay. Thindle asks, how you doing, my friend? How you doing? I'm doing absolutely beautiful. I hope you're doing absolutely beautiful. I know you're saying you're doing all right, but I hope we can turn that around. I hope we can make you smile. I hope we can make you have a great day. Thindle, I love having you here, my friend. Folks, do you guys know the incredible Thindle? Thindle. Thindle's an incredible streamer, .NET developer extraordinaire, host of the Captain Coder What emote, Cappy What. If you want to get your own Captain What, go check out Thindle. Thindle, we love you, my friend. It's so nice to have you here. What did I have? Hitana says, well, you have, oh, I saw that one. Didn't realize you could compare strings with the keyword today. I think it's new in .NET 9 or 10 or something. Is the pattern matching operator is in this case. Yeah, is doing pattern matching here. So I could do a dot equals as well, I think would be another one. So I think these are our base cases. These are our base cases. Otherwise, we kind of have to take one case at a time, right? We do one case at a time. We say, okay, well, what is, I know now that I'm here, that my input is not, my spring is not empty, or that I've broken things remaining. Oh, you think I can do an and there? For the pattern matching, it didn't let me do and, but that might just be because I'm not sure. McNets, I'm not sure. Kitty, I haven't got Thindle, I'm so busy, my friend. I haven't gotten it in there. There's so many things I want to get. There's so many things I got to get. I've been busy. Sijian wants me to do the outro. I got your video though. I just haven't added it in yet. I want to add in a little video for our very wonderful friend Nick as well. There's so many things I want to do. So many things to do, so little time, so many puzzles to solve. It is wonderful. I admit it. Okay, so now we it's just a simple way to do the same thing. Okay, so now we kind of want to look at our first input. So we want to say, we have three things here. Input, first character, examine next symbol, and validate this symbol. All right, so if it can either be a dot, a question mark, or a hash. And if it's a dot, we want to look at whether or not we're entering a group or like exiting a group. I always use is null, empty, or white space generally. That's good. G, welcome back, my friend. I hope you're doing well, G. It's nice to have you here. I hope all of your stuff that you were dealing with the other day went well. I like is more, it reads better, and it's closer to the style of C#'s Pascal ancestry. I really like is. My students really like is as well. I introduced them to some of the other stuff first. We sort of have... let me think about this. Let's look at this one here. Let's look at this example here. As I read this question mark, I know I have a 1 here. So I can say it's either going to be a hash or a dot. So when I have a question mark, I need to check if it's going to be a hash or a dot. And then continue there. If it's a hash, okay. So the recursion is a little bit like this. Springs, let's do char, ch, the first, char, next spring is going to be our springs at 0. And then string remaining is going to be our, not string array, remaining is going to be our springs of 1. So we take everything after, oh, can I not do that? Unnecessary assignment, the local variable cannot be declared in this scope because the name is already, oh, I already have a thing called remaining springs. There we go. Max Crewer, what up? Follow Max Crewer. Welcome to the crew. Today we've got Max Crewer following me. Max Crewer, thank you so much for the follow. Happy to have you here on this beautiful Tuesday, my friends. And then we sort of want to do something where we do process springs. And we're going to do, the idea here is we are breaking off remaining springs, and then our number here, next springs, whatever, next broken, and then remaining. kind of gets propagated down, but we got to do something special. We'll call this remaining configs, something like that. I got to figure this out. So we'll say if next string is a hash, this means we're broken, right? It means we're broken like this. So we need to reduce next, it's going to be broken -1. So we take one out of there. There's something special when we get down to 0, there's like a special case. Are you going to do emulators at some point? Explain more. I don't, you mean like writing an emulator? Yes, Nick, that is shorthand syntax for split, substring, yes. It's definitely not as consistent as it once was, I believe. So we have an int, next broken is going to be broken -1. So we found a broken spring. So it's here. We found a broken spring. And when you find a broken spring, we reduce the number in that group, but we do this by 1. We did, that could be a really fun thing to do. I've done it for, I don't know if I've done it on stream. I don't think I've done it on stream, but we've written a programming language on stream. Doing an emulator for bits, like a machine processor would be really cool. I would love to do it. One of my favorite puzzles of all time was this conference here. Let me get the link here. We might implement this emulator on stream, which was really cool. Let me see if I can find it here. 1 second. I thought I have it. Give me a second here. Give me a second here. I got to be distracted because it's my favorite. It's like my favorite puzzle of all time. Why don't I have it bookmarked here? Programming, the task, bound variable, the task. This, the International Conference for Functional Programming, one of my favorite conferences. This, you have to, for this puzzle, there's a series of puzzles in here. You implement an interpreter. What year was this? 9th annual? I'm not sure what year this was, but I did this when I was in university, and this was super fun. So we might do this on stream. Again, I've done it before. It'd be a little bit cheating because I've done it before, but all of the puzzles there are incredibly. Manaliki, how you doing, buddy? Welcome back. Welcome back. Sorry, folks, I'm getting distracted. And Connie Dev, welcome back to the stream. How you doing? Hello. Okay, so if the next spring is this, we have some other cases. If it's a dot, yeah, so if it's this, next broken. All right, so there's some cases here. So if we have a hashtag, if broken is 0, if broken is 0, this isn't an invalid configuration. Because we found a hash, and we said, well, this group doesn't have anything else broken in it, so we return 0. We don't have to do anything. Otherwise, we reduce the broken by 1. And then we continue. We return this. Okay. If broken was 0, we can't possibly be in a valid configuration because we just found a broken spring. Okay, we found a broken spring. If there are no more broken springs in this group, we cannot possibly, we are in an invalid configuration. So we return 0. Otherwise, we remove a broken spring from our value and we continue processing. Okay. If next spring is a dot. This is the other simple case. The question mark, we do a split. We have to check. We'll end up replacing it with a hash in one case and a dot in the other case, and then we'll continue the count here. Okay. Dr. Trojan. I'm assuming Dr. X Trojan. Dr. X Trojan, I would like to welcome you to the crew now, Dr. X Trojan. Thank you for following me. Thank you for following. I appreciate it greatly. Thank you for following, and I hope you enjoy your stay. Dr. X Trojan, what a great name. Thank you for the follow. Happy to have you here on this beautiful day. All right, so if the next spring is a dot, it's not quite that easy. It's not quite that easy because we don't know whether or not we were in a group yet or not. We kind of need to know whether or not we're coming off of a hash, right? So what's important here is if we have a hash dot. When we have a hash dot like this, if we have a hash dot, as we're coming off, when we see this, we need to have broken equal to 1 to be a potentially valid. If broken's not equal to 1, we're invalid. So I can't look at just the next character, I don't think. Come on, I've had a chair with more musical talent than you. Look, we all love a good game of musical chairs. And look, I'm doing my best. Come on, Francisca, I'm so sorry you're suffering. Look, we can all suffer together. You watch me being tortured, I get to torture you a little bit. Them's the rules. So I don't know that we can actually just look at the first two. We got to do something a little bit different here. Yeah, it's a little bit different here. Sir, this is a programming stream. I'm reading that into like this. This is a Wendy's. This is Lila, Lil Ya Pluma. Welcome to the stream. Happy to see you. I'm not saying the chair had any musical talent. It was just perfectly normal chill, and it still beat you. It happens. Look. Don't make me bust out the guitar. I'll do it. Don't make me bust out the guitar. I have a guitar right there. We'll do it. And then we'll see how little talent I have. You ain't seen no talent yet, Kavadra Tisk. You ain't seen me with no talent yet. Remaining here, really, in this case, I almost messed it up. This should really be here, like this. I am truly square. Travel the world, thank you for your lurk, my friend. Enjoy your lurk. You're welcome back anytime. And I hope you have a beautiful day. If it's a hash here, we want to check one other thing first. We want to say if springs.starts with hash dot. Okay, so I have this little case here. July Kumar over on YouTube says, I thought it's Python. We're doing, this is C#. I'm doing mine in C#. But welcome to the stream. It's nice to have you here, my friend. It's like geometrically. That's okay, though. We're doing it in C#. If we start with a hash dot, if broken is not equal to 1, we are not valid. Does this make sense? Enjoy your day, Smab. I hope it's wonderful. Remember, Smab, to keep coding, keep growing, be the best you can be, and you're welcome back anytime. I can't wait to see you again. Best of luck. with your endeavors, my friend. Have a beautiful day. If broken is not equal to 1, if broken's not 1, we are no longer in a valid group. All right. If we found the end of a broken spring group. July, let me know if I'm pronouncing your name correctly. July, is it Jalaj? I'm not sure how to pronounce it. It's okay if I call you Kumar. That's another option. First time here, your charismatic behavior hooked me in, although I don't even usually participate in AOC. The inventive code of try hack me. Nice. I should really do more of that stuff. It's one of my weaknesses. I haven't done enough like hack the box stuff. I think that'd be really, really good for me. But yeah. Well, thank you for being here. Hi, 10 down. I gotta go. We'll be back in about half an hour if you're still streaming. It looks like I'm gonna be here a while today. Enjoy your break. Looking forward to seeing you back in a moment. But we're gonna work our way through this. Thank you so much for the compliments. Thank you for being here. I love having you here, my friend. But yeah, if you want to as well, you can join the Discord. If you wanna hang out with other people in the community, feel free to join the Discord. And we have a lot of fun over there. Okay. Otherwise, we have if it is one, we've found the we could also do this. If it is equal to 1, you know what? If it's equal to 1, we have found a potential. There's potential here. So we'll do a process springs of 2. We take the rumor, broken. We found the end of a group. Oh, you know what this means? We found the end of the group. We got to pull the next set off here. That we found the end of the group. We're going to pull the next set off here. So we're going to do this. This is our remaining. Here, we're going to split it like this. And this becomes nums of 0. And this becomes rest. Sorry. Int dot parse nums of 0. Okay, check that out. So we just found the end of a group. So we have to pull off the last chunk of the remaining stuff here. If it's 1, if it's 1 here, there's going to be an issue. I'm going to have one minor issue here. I don't think part 2 would be an issue, so you might be quicker than you think. All I'm going to say about part 2. Thank you for the little hand there. Captain Discord is great. Such a fun, much learned. Nineberry. Yeah, I'm going to replace it. I'm going to replace it once with a hash and once with a dot, and then recur on each of those 2 paths. That's my plan. Topologist, great question. I want to be able to memoize this function. If I put it in a vector, then I have to do extra. I can just hash this input here. I can just hash into a dictionary very quickly. And if I use a vector, then I guess I could turn the vector back in. I also am doing a recursion, so I don't want to be manipulated. This forces me to have immutable types. I could use like an immutable vector as well. Exactly the same as mine. And mine is 100 times better. Spoof! All you gotta upgrade that computer. The best optimization, just upgrade the computer. Yeah, so I think you could also have a bigger or a more challenging input as another option. What you're trying to do yet. So hanging in there. Nick, we're doing our best. I'm not quite sure I know exactly what I'm doing yet either. But yeah, topologist, I'm not a big fan of what I'm doing here either. There's one little problem we're gonna run into is if remaining is empty here. If remaining is empty, we need to kind of only have dots left at the end. So I'm slightly worried. I'm wondering, do we have a case where we have ... and then others. All right. We have 1 and then we have an empty string here. If there's an empty string, there's a special case here as well that I don't know that we meet up here. So if we have a 1 and then the empty string, then there's a little bit of an issue, because I'm going to try and split on an empty string, and I'm going to get a length of 0. I'm going to get a length of 0. And then this is going to, this won't parse into an integer. So I imagine we're going to end up with that case. So I think I have a problem. I think I have a problem here, where I can't break it. And what I could do is I could say if, and I look how nested this is getting. I'm not liking it. If broken is 1 and remaining dot is the empty string. Broken 1 is remaining is the empty string. We got to do something a little bit different. Okay. So in this case, we're going to do a return process springs of springs 2 dot dot 0 empty. So this will get, if I do it like this gets us to our base case of 0 empty. Okay, so if remaining happens to be this, we're going to force it to go to our base case. Else, if broken is 1, we can do this, because I know this is no longer empty. If broken's 1, pull off the next number. Find the count for the next number to process. Okay, the next number, the next group, find the of broken springs. Okay, we find the next group of broken springs. Else, if broken isn't equal to 1 and we see this, it's saying we're at the end of a group, we actually can stop here. We say we actually don't have a valid solution here. There are no more valid solutions. No matter what we do, there's no valid solution. So if we have a hash dot, there are no valid solutions. Okay. All right, so this is where our group is broken, where we break a group. If we make it here, look how horrible this is. I hate this so much. But we're going to keep going. So we're going to pull off the next thing. Now we say, okay, if it happens to be a hash, we know it's not hash dot. We can just keep going. Here and say, we'd say, okay, just go to the next spring. Broken here. There's an optimization that I might do. I could find the number of hashes and pull them all off at once. Find the sequence. Hang on. So I know if we have a hash here, optimize by pulling all hashes off. All right. So there's an optimization to do it where I could quickly say, well, pull all of the hashes off, but I'm going to be lazy here and just pull 1 off. I'm just going to pull 1 off. All right. So there's an optimization here where I could find out where I should break here. Butts, exactly right. Exactly right, Thindle. We got a lot of butts. We're gonna be a little suspicious about that. I'm watching you. Jeff's watching you as well. Okay. So we're gonna process our springs here. If the spring is a dot, we also just kind of continue, but our broken doesn't decrease. Broken continues here. So if the next, we found a working spring, so we just continue. Again, there's an optimization where we pull off all the dots. Like this. Okay, so there's an optimization where we pull off all the dots and continue here. The question mark case. This is where we end up not being tail recursive, which is a little bit disappointing. We could pass a count in. We'll do it without tail recursion. All right. If next spring is a question mark. Down here, throw new exception, made it to failed to yeah, hopefully we don't get a Stack Overflow. Our inputs are really short though. Our inputs are really short. If we look at our inputs, the inputs that are coming in are relatively short here. So I don't think we'll get a Stack Overflow. These are all relatively short. So each one of these will have, I'm gonna, you know, the longest one here looks like 10 or so. So we'll have 10 stack calls. We shouldn't end up with a Stack Overflow. Encountered invalid character next spring. Okay. So if we find a question mark, we want to return the sum of, so we'll do it long valid configs. So we're gonna process it here. We're gonna process springs by putting a hash at the front. Can I combine strings like this? I'm pretty sure springs of 1 broken remaining. We basically sum these up. Valid with broken, and then we'll do valid with working, like this. And so we say, okay, well now we need to find what the answer is by swapping in each one. So we're gonna pure mutate this here. And we just sum up valid with broken and valid with working. I think this is this is my first, I think my logic here is sound. I think my logic here is sound. When we get to the end of a group, we have to do something special. If it's just a hash, we know this is hash isn't followed by a dot, so we could potentially pull some extra off. There's something we could do special where we have a dot and a hash, where basically we want to pull these off until we get to something that's like a dot and a hash. I'm hoping this will work-ish here. Otherwise, the debugging of this is going to be a challenge. Jada LPB, thank you for following me. Today we got Jada LPB. Thank you for following me. Thank you so much for the follow, Jada LPB. Welcome to the stream. Happy, what is today? Tuesday. Happy Tuesday, my friend. Let's see. I'm gonna do it from the terminal because let's do a build. Let's run our tests. .NET test. I can't possibly get this correct on the first try. We passed one. We failed 6. Okay. We passed one, we failed 6. Ooh, that's an interesting idea. Okay, we passed one, we failed 6. It doesn't infinitely recurse, which is good. I just wanted to, if it's infinite recursion, VS Code takes control of everything. So we worked on one input. Here. And we failed on others. And so let's build up. You're here for the hot tub springs. Yeah. They're not hot tub springs. They're springs that are hot. It's not, no water involved. These are hot, bouncy springs. Welcome back to the stream, JD. How the heck have you been? Folks, did you guys know JD does dev? JD does sax. JD does it all. JD does impersonations of the captain. Check it out.
I want to feel like you're talking with Captain. Let me
calm down,
see
Thendal.
if I could do my Captain impression. I am not the captain, but my eyebrows also move in a way like the captain.
Thank you for the impression, JD. Folks, be sure to give JD a follow. Be sure to give JD a follow if you want someone do some coding, learning some Godot, making some interacting with this Twitch API, making a stream game. Really cool stuff going on there. JD, how the heck have you been? How's your new job going? You just got a new job, is that correct? Little Naya, I hope I'm pronouncing that right. Sorry, little Naya. Thank you for following me today. We got little Naya. Welcome to the family. Thank you so much for following. I appreciate you being here. Welcome to the crew. If you have any questions, do not hesitate to ask. We're working on admin of code today, day 12. It would mean 20-digit long permutation count. So no, this will never complete for me. Sorry, Nick. All right, let's take a look here. It did correctly pull. I should have put it up here to begin with to make sure nothing got pulled off wrong. Let me put it here. I'm going to put one there just so I can see the initial call as well. Debug test. It's a good question. It passes on one of them. Maybe I should look at what the outputs are. That's a good question. Let's run the test. Let's see what we get and what it's supposed to be. 9bear, does it return 0 or more than expected? That's a good question. Does it return? Do they pass sometimes? What's happened? Oh. I didn't mean to cut. This should have been... All right. That was crazy to me. I was like, wait a minute. This is insane. I accidentally removed the test. So of course it failed here. All right, so we can look at this, these tests here. Expected for should be broken remaining. Dragon. Yeah, it's almost like there's a 1 plus something that I'm missing here. Maybe it's not. It shouldn't be that bad. It I don't think it's that bad. It might be. I'm missing a +1 here, I think. It's almost like I need 1 plus, but only if this is valid, right? So I don't know if that's actually valid. Really, at the end of the day, I'm gonna end up with like a bunch of +1s all together. Or zeros, and that's where I want to be. Let's do one. I'm gonna write a test here. We're gonna step through this one. This one doesn't feel too long. We're gonna step through this one. We're gonna debug it, and we're gonna make sure everything makes sense. All right. Otherwise, we're just guessing. And I don't want to guess. Let's make sure we split this input here. Okay. And let's make sure our parts is correctly split. We didn't lose any input. 1 and then 1, 3. We didn't lose any inputs there. And then we process this. All right, so let's step into... We are doing this. The first chunk is broken is 1. And I might need to write some stuff down here. Dragon King, no, thank you. Thank you for being here. And let's keep going here. If the spring is empty, it's not. We step over. So we're going to skip this. We still have work to do. The number of broken things are still there, so we still have work to do. We don't start with this, so we jump over it. And we say, okay, what's the next spring? It's not a hash. It's not a dot. It is a question mark. Okay. So it's a question mark here. And so now we want to say, put this hash at the beginning and then step in. and then step in. So we step into it. Okay, so now we're checking the version that has the hash question mark. We're going to be able to jump past this now. Broken is still going. We didn't modify broken at all. We still don't start with this, but we do start with a hash. We do start with a hash. Broken is not equal to 0. So we have to do more work. Okay. So we're going to pull. I see where I've gone wrong. I see where I've gone wrong. I see where I've gone wrong. Immediately see where I've gone wrong. Okay. You mean this case where hash is at the end and finishes the group? Exactly. Exactly, Nineberry. So if hash is at the end and finishes the group, so if I step into this, we're going to notice I'm technically at the end of a group here. And so there's this case where if broken is currently, I need, let me think about it. But I see my problem because I do this to detect it, and it's not detecting it. Bad cops. Yeah, I don't know how you do bash, this type of thing with bash without a debugger. All right, so because what's going to happen is we're going to come down and say, oh, well, we must be a question mark. So then we're going to do one with each, but I'm missing the previous symbol here. I'm missing my previous symbol. And so basically I'm going to do a hack. I'm going to do a hack. If springs.starts with question mark. Do I end up with the same thing if I do this? I think I have a problem if I do this. I have a thing here where I say hash question mark. Ow, thank you for the raid. Ow, thank you for the raid. Thank you for raiding. Ow, thank you, my friend. Thank you for the raid. Hands up. This is a raid. I'm sorry. Don't shoot. I ain't never done nothing to no one never. I ain't never done nothing to no one ever. Stony Eagle, welcome to the stream, my friend. Just there's no O in there. I see an O though, it's just not pronounced that way. Thank you so much for the raid. Heyo singing. Thank you for raiding. Thank you for being here, folks. Hang on, we're gonna make this last longer. Thank you so much for being here. We're gonna get that little follow button. Get that little follow button, but let's give a shout out. Thank you so much for the raid, my friend. Folks, be sure to go check out Ow. What were you working on? Folks? Right here in your chat. Attention all lurkers. Click this button right there. You see it. Click it. Give them some love. Thank you so much. For the follow, my friend. Oh, the raid. Thank you for being here. What were you working on? I can only imagine doing advent code, but I could be wrong. I love when I can instantly hit the follow button. Stony Eagle, thank you for the follow. Stony Eagle, welcome to the crew. Also Nahalian, welcome. With the double raid, holy cannoli, Proton raiding in with his people. Ow, raiding in with you. We designed a related stream on my side, but I'm trying to learn JavaScript. Gotcha. Nahalian. Let me know if I'm pronouncing it. Nahalian. Thank you for the follow. Today. We also got Das M Dota 2. Can I just call you Dota 2? Dota 2. Thank you for following me today. We've got Dota 2 following into the crew today. We also got Proton Fig. Thank you for the raid and welcome today to Captain Coder's Academy. Oh no. Thank you so much for the raid. I'm so happy you guys are here. I'm a nutter. Look, It happens. It happens. Look, we love having the people here. We love the code and we love the crew. Proton, I hope you're having a beautiful day. We're gonna give you a shout out. Someone help me remember to give Proton a shout out once we have the cooldown off. Once the cooldown's off, we'll give you a shout out. We are working on the advent of code. We are working on the advent of code day 12. Day 12. You didn't get it. That's okay. That's okay. It's sometimes it takes a little time to get going on these things. We're doing day 12, which is definitely a tricky one. It's a tricky one here. Okay. There's two cases here we're examining that we got to examine here. I think we might have to do dot question mark and question mark dot hash question mark. If it starts with this, we kind of are okay. Hexrex, this is VS Code. That's correct. That's correct. It is VS Code. If you're curious why I use VS Code, it's because I'm a computer science teacher. I teach computer science and programming at a school, and we use VS Code at that school. We do a bunch of different programming languages, and we have students learn this one tool rather than a bunch of different ones. That's sort of what we do. We use Replit a little bit too. Some of the classes. Stony Eagle says, what do you do normally outside of Christmas time? Well, I'm so glad you asked. My name is Captain Coder. Captain Coder is me, and me is Captain Coder. And Captain Coder is a computer science educator. I teach computer science and programming. My full-time job is teaching computer science and programming at a school for ages 10 to 14. 10 to 14 is my full-time job. I absolutely love it. It's the best thing I've ever done. It's the best thing I've ever done. It's the best job I've ever had. I absolutely love it. The stream here, I started last year doing Advent of Code to record videos for my students. We had an algorithms class. I taught a class called Introduction to Competitive Programming, and I streamed myself doing these so I'd have a stream of consciousness for them to watch me doing it, and then I chopped them up into some videos for them to do. Executio, in US it'd be considered middle school, yeah. And so, outside of it, I wasn't planning on streaming more than 25 days. I just kind of fell in love with it. Outside of that, we do data structures and algorithms. We do game dev, and we do a bunch of collab streams. So I teach people programming. I do a collab stream with some people who are learning to program, so you can watch me give live lessons. I do data structures and algorithms, where we'll look at one type of data structure, one type of algorithm, we'll talk about it, we'll learn something about it. And then we do game dev, where we look at game dev concepts. In Unity, I've done some Godot stuff. We're doing some custom engine stuff. Yeah, super exciting stuff. Sorry if I missed something in the chat, but I want to welcome Batuhan Babes. Batuhan Babes. Let me know if I am saying that correctly. Batuhan Babes. Welcome to the stream today. Welcome aboard, my friend. Happy to have you here on this beautiful day. Sorry if I missed something. Let's see. Do you share what level? Yeah. It's an online school, 100% remote school, so it's international. But I hope that answered your question. Just send me more here. Stony Eagle. Call me Stony or Mr. Eagle. I'll call you Stony. Stony. I'll try to call you Stony. I might forget. But I'm so glad you're here, my friend. Happy to have you. And EXE, thank you so much for being here as well. Anonymous 001, happy to have you here as well. You guys are all incredible people, beautiful people. Hex 0RX, Hex. I'll call you Hex. I have done so my when I was in industry, I did a bunch of stuff with machine learning. I haven't taught neural networks, but that would be the doing neural networks isn't that bad. If you're implementing from scratch, it would be a little bit trickier, the statistics and stuff on it. But if you just want to use some frameworks, doing a neural network stuff is really cool. One of my favorite projects is to implement a neural network to play Flappy Bird. When I have done it, I did it at summer camp once. We introduced neural networks to play Flappy Bird. And so it just learns when to press space based on the screen input. That's one of the best ways in my mind to learn it. Another one is learning how to do script recognition, so handwriting recognition. That's how I learned neural networks, was writing an implementation of that. Okay, I didn't mean to end. I did discover. Okay, so we have these cases here where we have a hash question mark and a dot question mark. I haven't done much with blockchain tech, Anonymous. Yeah, I don't know much about blockchain. I've done very little with it. I've done a little bit more with cryptography, but not necessarily blockchain tech. So not a bunch with neural network and stuff. Yeah, OCR recognition. I just couldn't finish it. We wrote an OCR using neural networks in my machine learning class when I was in college. When I was in university, we did neural networks. We implemented that. Isn't blockchain just Symphony? Well, that's just like, some people's opinion, man. Do you have your bean water break yet? Not yet, G. We're going to go another 10 minutes. We're going to go another 10 minutes, then we're going to do a bean water break. But before that, I want to thank Proton for the raid. Folks, if you guys don't know Proton, if you want to watch an epic, legendary programmer working in assembly, making games for Commodore 64, look no further than the absolute legend Proton. But you see that cart there? Cart King is a game Proton's making for the Commodore 64. It's insane. It made this music. Just absolute legend. Be sure to give Proton a follow, folks. See that little heart? See that little heart? If you're not following Proton, you gotta go check him out. Incredible stuff going on over there. I love that you're doing assembly all the time, Proton. Thank you for being here. Thank you for the raid. Thank you for bringing your crew in. Okay, so we have to think about the situation here. If we have a hashtag coming in. So for people who aren't familiar with Advent of Code, so we got some new people here. We are doing Advent of Code. It's a little series of puzzles. We're doing day 12 today. This one's a little bit tricky. We have these inputs. This one's tough. This one's actually, I think, the hardest problem so far this year. We have these rows of inputs that have these question marks in them, hashes and dots. We are trying to determine what are the different combinations these question marks could take on to satisfy these series of numbers over here. The numbers on the right tell us that there are groupings within this string of hashtags. So for example, in this row here, we have a hashtag because it's a 1, it's a group of 1. We have a hashtag that's another group of 1. We have a 3, which is a hashtag group of 3. And then the rest of these have to be dots. Down here, we have the question marks, and we need to fill in the hashtags and dots and calculate how many different permutations we could have of that. So for example, here, we know that we have 3 groups, 1, 2, 3 groups. We know that the first group has only 1 hash. It can be either one of these. So there's 2 options here. There's 2 options here. And then this last one has to be a group of 3, so it has to be this. So those are our options. Anonymous says, I think those are open source APIs. Sorry, I missed something. If you like blockchain stuff, I wrote a tool to generate C# code to interact with Wax blockchain. Very interesting. Yeah, I know very little bit. I know just enough about blockchain. But I'm not in it like a crypto enthusiast or anything like that. All right. So we are writing a recursive solution that will calculate these, and it's getting pretty gnarly. I'm not very happy with my solution so far, but we discovered that we have a bug in our code where we're not accounting for the case where we have a hash followed by a dot, And when we have a hash followed by a dot, there are 2 cases. It's either that there's 2 cases. This got to be a hash dot or a hash. And so we want to say if if the number in our group is 1, we have a valid solution if this is a dot. It has. Is that true? Yeah. So this has to be a dot if that's the case. So there's also, I think we could do something stupid or more naive here, where we do a process. We do this thing. We do this again. We do something a little bit more naive, where we actually will append hash to this, or a hash dot. Can we do this? Could we technically do this if we account for that situation, if we have a hash question mark? I also think I'm missing where we just have a hash at the end. If next string is hash. No, I think we account for if we have a hash at the end. Can we do not hash and dot? Can we do this? Is this? Let's test. Let's run our tests. I probably should have waited. I might have an infinite recursion. I probably should have done it from the terminal first. Okay. This is a really... We have a something that we believe is working for calculating it here. There's some major efficiencies we can do to solve this. There's some major efficiencies we can apply if we wanted to solve this. G, enjoy your day, my friend. Have a beautiful day. Remember to keep coding, keep growing, be the best you can be, and you're welcome back anytime. You know I love having you here. Yeah, enjoy. So someone introduced me to the term touching grass the other day. Apparently I'd never heard that before, but enjoy your time out. Yeah. At GTab, it gets dangerous. It gets dangerous because you get I do that all the time. All right. Prophets, staring at my wall of glory, my wall of obsessions, my wall of obsession back there. You guys see, you know I love them board games. My wall of games. Folks, if you want to watch Captain Coder play board games on stream, I do collab streams with Dungeons and Dimples. Dungeons and Dimples, incredible variety streamer. We gotta follow by Iowa. Let me get back to that in just a second. Iowa, thank you for the follow. Iowa, have a beautiful day. Iowa, have sweet dreams, my friend. I hope to see you again soon. Take care. I'm gonna check out your stream the next time I see you on and I can get in there. And anonymously 001, you're like a secret agent. Anonymously 001, anonymously 001. Thank you for the follow. Thank you so much. Anonymously 001. Thank you for the follow. I tried the Mission Impossible theme. Mission Impossible. What I was saying, if you guys don't know Dungeons and Dimples, friend of the stream, incredible human being. We do collab streams together where we play board games. She does board games on her stream. I've joined her. We played Marvel Champ. She's super cool. Be sure to check her out, folks. Dungeons and Dimples. Give her a follow.
She's taken particular offense to this pile of snow and is just attacking it with all of her arrows. What are you doing, honey? Die, snow.
Dungeons and Dimples is hilarious, folks. If you guys want to watch someone who does fun variety stream, retro games, a little bit of a cozy stream, board games over there. I play board games with Dungeons and Dimples on her Discord, on her stream. We've done some collabs together. We're going to be doing some more next year. Be sure to click that follow button. Give Dungeons and Dimples some loves. We love Dungeons and Dimples here. All right, so we have a solution here. We're going to test it. We got to actually write our solution here. Are you trying to get more time to think? No, Kvadratisk. We have solved it. It's going to be super slow. We just have to memorize it here in a second. So I'm going to show everyone. It works for our sample input. I just need to break it into lines. So we need to parse it out. So we're going to do input dot split on environment new line. Didn't you want to switch the line? I'm going to. So for my test data, the new line, it's fine. For my test data, this is fine. I need to do it for my input when I download it, though. I need to be consistent in my input when I download it. So this is going to be, we're going to split it like this, and then we need to process for each one. We're going to call process strings, and then we do a sum. So this should be our solution here. Let's run on our sample input. Dun, 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 dun. Come on. There we go. Sample input passes. We got to go get our actual inputs. Go get our actual inputs. And this is the one where we have to change the line in inputs.txt. We got to change. So notice I'm on Windows, so I'm going to switch this to CRLF. Just to save myself some pain, because last time I didn't. We could also do not even for Unix platforms. New line is not null here. Yeah, I could write a better split, if I'm being completely honest. I could make this take in a string array input. Might be what I want to do. We're okay. We're okay. As long as we're aware. As long as we're aware. This is essentially what Smab was saying yesterday. It's like, as long as you're consistent in your solutions and your implementations and you're aware of your environment, you should be okay. That said, I am such a Linux nerd. I feel like new line should always be /n, and using anything else is sacrilege, blasphemy, blasphemous to use non LF new lines. Backslash, you mean? I don't quite understand the context. Yeah. So on Windows we have backslash n. Yeah, backslash. No. Yeah, this is backslash. This. What type of character term again? You said /n. Yeah, you're correct. I meant backslash n. I meant backslash n. Thank you. All right, so here's our inputs. I've done that. Let's make a copy and drop this into our test. Here. Paste. There we go. So now our, you know what? Maybe I should really do this for my input. Let's not get crazy. All right, here we go. Go to our test. We'll get our input here. Public static read only string. Now I'm confused. Puzzle input equals file dot read all lines input.txt join, and then we'll do a join string. Here we'll do it. String dot join. We'll take the extra environment dot new line. We're gonna do this. We're gonna take the little extra little bit extra to make sure. Just to make sure here. Enormously backwards up to Windows 11, where they have or at least had stupid hardware lockouts. Interesting. I know they always do crazy backwards compatible stuff. They put a lot of effort into making it possible. Test puzzle input part 1. This should be sample input part 1. And we're going to go with our puzzle. It's true, Nick, you are correct. It's true. I'm just making sure we have the environment new lines. I want it to work on any system. Reads all the lines. I'm really curious if read all lines does something smart. Yeah. But Nick, my input here is a whole string. You see where the challenge arises? You see where the problem is coming from? You see my predicament? I do because my solution requires this. It's my party and it's my party and I'll join if I want to, split if I want to, join and split if I want to. You would join too if it happened to you. All right, so it finishes and we get. I just ran out of bean water, so this is a good one. I'm aware of what's happening. I shouldn't put that in here yet until we've tested it. Boom! 1 gold star. Okay, I spent a lot of time to understand VS Code and setting up MinGW. Nice. Captain, why my VS Code not printing results in output tab? What settings I need to change? If anyone knows, please. So it depends on what your output tab is. Your output hex, make sure you're in the correct dropout. So we have a bunch of different outputs here. So you're saying it's not printing in the output tab? Like, what are you trying to output? What are you trying to read through here? Usually your output's gonna be coming through the debug console or the terminal. So output is more for logs. I very rarely use this. It's more for logs to understand what different extensions are doing. All right, folks, we do have to take a break. When we come back, we're gonna look at part 2. We are gonna look at part 2 when we come back, but we got a solution here for part 1. We got our first star, gold star. We're gonna come back. I gotta get myself some more bean water. I'm out of bean water. Make sure to get your own bean water. I'm gonna get myself some more fresh water. And when we come back, we're gonna keep going. But first, we're gonna do some stretches. So get your mom, get your dad, get your cousin, get little Bobby, get your dog, get your horse. If you got a horse, of course. Get it in the room. So we're gonna get some stretches. We're gonna do it all together as a crew. So hang tight, everybody. The captain shall return momentarily. All right, folks, the captain's back. I missed you guys, but I'm back. We're gonna get back into coding. Don't you worry. Don't you worry. The code is still there on the desktop. Look, there it is. There it is. I told. See, look, nothing to worry about. Just because. Oh my God, is the captain gone? Just because you can't see me doesn't mean I'm not there. Just because you can't see the code doesn't mean it's not there, folks. Object permanence is a real thing. Object permanence, hopefully you guys have developed that skill. But before we get back into the code, we gotta take care of ourselves because we've been going, my room is sideways. Hang on, let me fix my room real quick. I gotta rotate my room back up. There we go, I fixed it. Sorry, the room was at an angle, but we got it fixed here. Object-oriented permanence, that's right, bad cop. Look, the captain loves you, which means you should
in the back. Pay attention.
Graham, I see you back there diddling around, not doing your work. Pay attention, my friend. Look, the captain here loves you, which means you should love you. And if you love yourself, you gotta love that body. One way you can love that body is getting some stretches. So I'm gonna implore you, I'm gonna engorge you, I'm gonna encourage you to stand on up with the captain here. Where's my coffee, Stony Eagle? We got Stony. I got myself some bean water right here. Ooh, it's just too hot. It's too hot. We gotta do something when we wait for that coffee to cool down. Gotta do something when that coffee to cool down, and we're gonna get some stretch in. That's right, JD. We're gonna engorge you because we're gonna get that blood flowing. We're gonna get that blood flowing into all of your limity lambs, and we're gonna get ourselves nice and engorged. Get that heart pumping. Get that body fueling. But stand on up, everybody. Stand on up. I see you back there. I see you back there diddling around. Get on up. Get on up. We're gonna get some stretches in. Go ahead. We're gonna start get a forearm stretch in here. We're gonna get a forearm stretch in here. Grab those fingertips and pull back to get a little bit of tension in that forearm, and you're just gonna hold it there once you have that tension. Mazja, hi there. Holy moly, says nice game. Holy moly, they say. I don't know if you're there, he or him, or she or her, or they or them, but I'm gonna go with they. Mazja says they. Hi there. Oh boy, nice game collection. So many gyms in there, and getting along with the gym time. Exactly. I love me a good board game. Go ahead and roll that wrist out. This is a coding stream. Look, we got to take care of yourselves. Look, Captain Coder has carpal tunnel. You don't want carpal tunnel. Look, I sit over, if you're like me, you sit over a computer, you're hunched over like a coding troll all day long. Maybe you're not a coding troll. Maybe you're an internet troll. Whatever type of troll you are, controls deserve love too. Now grab those other hands, pull them back here, get that stretch. We're going to hold it for 15. Hi, Tendon, what happened? We finished part one. I haven't read part 2 yet. But we're doing part 1. We finished part 1. We did it with a recursive solution. We didn't do it solve without memorization. My guess is the next one is like you combine them all into one big long thing or something. I'm not 100% sure. Go ahead and roll that wrist out there. All right, folks, we're getting another stretch in here. Go ahead and reach up as high as you can. Oh, get that nice stretch. Maybe lean back a little bit as I can. Take a deep breath. As you exhale, hinge at the hips here. We're gonna hinge at the hips, and we're just gonna hang. We're gonna hang here for 20 seconds. Oh, get that nice back stretch in here. You're focusing on the lower back and the glutes on this stretch, everybody. Lower back and the glutes. Focus. Don't try and arch your back, touch ground. Instead, keep that back. Focus on just getting that lower back stretch. Lower back stretch, and we're gonna hang here for 10 more seconds. In a moment, though, when we get to the end of this, we're going to breathe in for 5 seconds. As we do, we're going to roll on up. So breathe in with me for 5 seconds. Roll up slowly in. When you get to the top, roll those shoulders up. Back and down. We're going to some shoulder rolls and back. 2, 3, 4. Add the elbows. 2, 3, 4. Full arms. 2, 3, 4, roll it forward, in, 2, 3, 4, add the elbows, 2, 3, 4, full arms, 2, 3, 4. Oh yeah, shake it out, folks. Shake it out. Thank you so much for joining me in those stretches. Just some quick stretchy poos today. Just a quick stretchy poo. We're gonna hop back in. It's got a little bit of a limited time, so I don't want to spend too much time on the stretches. We want to make sure we get our blood flowing. We want to make sure we're doing well. We want to make sure we're taking care of ourselves. But we also want to finish Advent Code Part 2. So we're gonna hop back in here. Come back to my desktop. Maz. Let me know if I'm pronouncing it. Is it Maz or Maze? Recursion. I know it's funny if you look it up on not on YouTube. On Google, if we look at recursion, it says, do you have to click, did I just type it on? Oh yeah, did you mean recursion? Did you mean recursion? Did you mean recursion? It got me. It got me. All right. Part 2. We just finished part 1. I love it. I love it. Look, see recursion. Recursion. See recursion. OX4562 of 6C. Oh, let's see. OX456C 2 decimal. Should I call you 17,000? Thank you for the follow. OX456. C followed me today. We got OX456. C, thank you, my friend, today. Thank you for the follow. OX456. Miss Captain. Miss Captain, stop singing. I'm sorry. Kavadra Tisk. I'm sorry, folks, for joining me in those stretches. 250 points, all you beautiful people, for being here to witness me finish part 1, another 125 points, and for having to suffer through all of my singing, 50 bonus points. Kavadra Tisk, I'm sorry you had to suffer. All right, part 2. As you look out at the field of springs, you feel like there are way more springs than the condition records lists. Than the condition records lists. When you examine the records, you discover that they were actually folded up this whole time. To unfold the records, on each row, replace the list of spring conditions with 5 copies of itself. Okay, so this is not what I thought it was going to be, but it's similar. Separated by a question mark, and replace the list of contiguous groups of damaged strings with 5 copies of itself separated by a comma. Okay. So this would be... So we're going to get 5 copies of this with a question mark joining them together. And then 5 copies of our number. So I think we should be able to do the same thing, but the memoization is just going to be way, like, we're not going to be able to finish a big line like this because the recursion, it just explodes exponentially. So we're going to try memoization here. Because what's going to happen, especially when you have it repeating like this, memoization works. Gotcha. Because you have it repeating, you're going to end up with the same thing multiple times. You know, once we solve this chunk here, if we have solved this chunk here, then we can find the solution. There's just like whether or not this next one's valid with the plus one on that. Mass, thank you, thank you, thank you, Mass. Thank you for following, Mass. Oh, Mass. Thank you for following me today. Thank you so much for the follow. But first, we got to build up our inputs here. Let's go ahead, hop back into our code. Let's do a commit. Let's commit what we have so far. Git add, git gut, git commit dash m. Beat implement day 12 part 1. We'll push that up there. And now we need for day 12 for part 2. Every spring input just needs to be so let's do a public static string expand input int copies. All right, so it's going to take a string to expand a char join to join then a number of copies. So if we have a string, we have our input string here, we can return enumerable dot repeat a range. It doesn't really matter. Repeat to expand copies like this, and then we do a string dot join to join on our thing here. This will be our return here. Okay, so we can expand our inputs here on a string like this. And then we can do our process our springs. Okay, so part 2, public static. It's not quite right. This expand input isn't quite right. This is taking in, I got this wrong. String input here. We're gonna do something like this. Let's save this real quick. Our input here, we actually do input.split on a space. String array parts. So we need to expand input here. Let's create another. I liked what I had here, but it's not gonna work. Public static string expand. Look, Kabadra Tisk, it's all in good fun, I hope. It's all in good fun, I hope. Look, what I like to tell people is you're allowed to boozle me, just don't bamboozle me. Just don't bamboozle me. Cool dude is cool, it's true. Cool dude is cool. Cool dude. Thank you for following me. Thank you for following, and I hope you enjoy your stay. Cool dude, thank you for following the captain today. Thank you so much for the follow, cool dude. I appreciate you being here. Happy Tuesday. I hope you're having a beautiful day. Get some Q-tips. I'm sorry. Wait, was I too close? Was I too close to the mic? I'm sorry. Please forgive me, prophets. Prophets, I'm sorry I blew your ears out. I'm sorry. Look, folks, for having to deal. Look, I apologize for you having to deal with me. 500 bonus points for. Look, that should help you with your eardrum reconstructive surgery. Your constructive eardrum surgery. Reconstructive eardrum surgery? Whatever it happens to be. Do you have an unnecessary broad voice range? I am what's called a baritone. So I actually can't sing bass and I can't sing tenor. I'm like stuck in this no man weird land called baritone. When I was in choir, I always got the worst parts. But that's okay. That's okay. So we're gonna split our input here like this, and then our string left part is gonna be expand parts of 0 with question marks, and we need 5 copies, and our string right is going to be expand parts 1 with a comma 5 times, and then we return left. I know how to C# left space right. All right, let's just write a little test here to make sure this is insane. You got your IT 168 final today. Good luck, Jake. Jaco the Draco. Welcome back, Jaco the Draco. Are you the real Draco? Draco, I think you've taken on a couple different names, but I'm assuming it's Draco the Boozler and Draco Fad. But welcome back, Jaco the Draco. It's nice to have you here. Good luck on it. And Devro. I do have a brother. Folks, do you guys know Devro? I think I have one of these for you, Devro. Devro is an incredibly talented game developer, 3D artist. You got to check him out. Does stuff in Unreal Engine. How's your game coming along, Devro? Devro is one of the best 3D artists I've ever seen. If you love it, be sure to check him out. For each line, so you see how slow it is. Add a right line for each. See how slow it is. I'm gonna do a memoize on it, and hopefully we don't have any slowness, but I'll talk about why the memoization is needed and what makes it super more efficient. But I want to make sure I expand a bit. Oh no, I already know it's not going to work without. I'm looking at some of these rows here. It's like, yeah, this is definitely not going to work with all the recursions, because you got to think it's breaking out a binary tree. Every question mark becomes 2 options. So it's 2, the number of outputs is 2 to the number of question marks in here. And so it's just going to get insane. I was looking at some of these inputs, and these all inputs are pretty small, but like I'm pretty sure the number of potential recursions is 2 to the number of question marks. And if we double this, it's going to be 2 to 256 possible things that we have to calculate, and it's just not going to work. So I can eyeball that pretty quickly and say, okay, well, we're under like 2 to the 32, 2 to the 16. What's the longest line here? 2 to the 16, we got 65,000 different options. So if we have one that's 64, 2 to the power of 64, we're never gonna finish. There might be a direct connection with coding and cod. The fish, cod. I love me a good Alaskan cod. Game is slowing down. Approaching C# final exam. Good luck. So need to concentrate on that a bit. No worries, but added some new 3D assets this morning. If you got some links for Devereaux, feel free to send them along. And folks, we love, if anyone here is a streamer, I want to know, because I love here. And Fast Mama Jamma, what a cool name. Welcome back. Join the Discord, on the Discord. Let me know what you're doing. Some people don't like to be tagged, but I always love when people on my Discord, there is a share section. There's too many channels here. Over in the share section, I didn't mean to, calm down. I want to hide my secrets. Share down here. Let me know that you're a streamer. And when you go to stream, you can do it in the self-promotion as well, but something you can do here, which I've done this intentionally, test here. Something I've intentionally done here is when you stream, make a new post in your streamer post here, and it will show up who has been streaming. This will show, I believe, for the 3 hours. It'll say this person started streaming in the last 3 hours. So if you're a streamer and you want people, and you want me to see it, tag me, say at Captain Coder. Yo, it'll tag me, and then you'll have this thread here for about 3 hours so that I'll know. Good, I'll add my spam post here. It's mostly for me, but if you want to see other streamers and you just want to know what other people are doing, it's a good spot to do it. And I want more people to do it that way. I think it'd be great. But yeah, I want to know if you guys are streaming. Whatever you're doing, share your projects on the third Saturday of most months. We do a showcase where people come in and hop on the stream with me, share their projects, we check them out. All right, folks. Ramble over. Slash ramble. I'm Fast Mama Jamma. I have a Discord and I'm not streamer. That's okay. I'm working on an Android app to capture UFOs. Ooh, unidentified floating objects. You got to watch out for those floaters. My posts there. yeah, please do. Tag me in them. I always tell people, I think people get scared to tag me, but tag me in them because I always want to know what you're doing. I love, folks, if you looked at my, let me see here. Did I take a screenshot? I have I feel insanely kind of gross about my Twitch. They have the thing where you check out your year in your Twitch recap. That's what it's called. My viewer recap is crazy. I feel a little bit gross about this. This is my Twitch recap. I watched 4,000 hours, almost 5,000 hours of Twitch. And I was on Twitch 347 days this year. So please, give me more things to distract myself. I feel a little bit guilty about that. I feel a little bit guilty. Grumpy was my number one too. I'm a little embarrassed. I'm not going to show the whole thing because I'm really quite embarrassed about some of the numbers on there. It's a camera app that captures pictures of the sky and stores those with possible USOs. Fast Mama Jamma, that sounds really cool. Have you, Fast Mama Jamma, are you aware of Skinwalker Ranch by any chance? It's not the dressing, but the actual ranch where they supposedly have all kinds of UFO activity. I love that show. Cracks me up sometimes, just like the drama on it. But a lot of the UFO activity there is kind of cool, just to think about. Apparently, there's also a new thing. I just got a weekly recap from YouTube. Apparently, that's also a new thing they do for you as a creator. They actually have a test to see if you paid attention in them. That's cool. It's just the tip of the iceberg. Tip of the spaceberg. It's the tip of the spaceberg. All right, I want to make sure my expand input here works. It depends on what you're doing, Draco. Learn C#. You know I always recommend C#. It's my favorite. If you're starting out, it's my favorite favorite language to start with. The C# Player's Guide will get you where you need to go. Hi, Tentano. Well, one thing you can do is, if you see the hash, you know that next insert items are going to be followed by... Yeah, so I have a little to-do down here saying that there's an optimization I can do. There's an optimization I can do where I can pull off a bunch of stuff. But it doesn't help me in the case where I have all question marks. It doesn't help me in the case where I have all questions. I just want to make sure that I have my expand input working real quick. So I'm going to focus just for a moment. Just for a moment. That's not going to be the slowest part, is really what it comes down to, Highton. And if I wanted to do some like hardcore optimizations, I absolutely would do it. Test expand input. And we're going to do some theories on this. We're going to make this a theory. String input. String output. And we're going to do the following. We'll do inline data. Coming with this, we got to repeat it 5 times. Hang on. Their test was this. This becomes this. So just to give myself a sense of sanity here. The first line above. All right, we'll take the first line. Our next one here. This is just a sanity check. Just a sanity check. To make sure that we hope it's correct and it should become this. Just a sanity check here. Okay. And we should do day 12.expand input on input.should be output. We're just going to do a sanity check here. Make sure that this, our expansion right before we try and do anything crazy with it. Nick says, one of the slides was, here are your 3 best performing videos. Then you get another slide and then a multiple choice where you have to pick which video performed the best. That's hilarious. That's hilarious. Let's run this. I probably don't need to run them all. It's slower to run them all. It actually, I think when you run this, it actually multi-threads them. Okay, so our expand, I believe, is working. This gives me confidence. It doesn't tell me it's working for sure, but it gives me confidence. Kabadra says, no, I finished part 1. Let's turn that off. I forgot to turn it off. We finished part 1. Part 2 is never going to finish by default. So what I'm going to do is I'm going to memoize process springs. So I'm going to write a public, I'm going to make this one private. Here, sure. I'm going to show you guys how I tend to do this. I'm going to have a return 0 here. This is going to be our private static process springs. And because I'm going to put an underscore in front. This is like our helper. This is our helper thing that we do. Notice these still call the original process springs. That's the important thing. These call the original process springs. This one's going to be memoized. So the way memoization works, does anyone want a rundown of memoization? I can do a rundown of memoization before I do it here, because this particular one's a little bit tricky to understand. Let's do a rundown. We'll come down. We'll make a temp directory here. Make dir memoization demo. So we're gonna do a rundown here. .NET new console. We'll do a rundown of what memoization is, how it works, and why it benefits us to do this. Exactly. We're caching it. We're caching the value. So let's imagine we have a function. I'm gonna make this an async function so I can make it take a while. Perform call. We have an input here, string input, like this. Okay. Perform action. We'll call this perform action. We're just going to return we'll return a string. Hang on. Put an int here. Int x. This is going to be a really dumb thing where it just says x squared. We're just going to do x squared. But we are gonna do a before we do it, we're gonna wait task.delay. We're gonna say this operation takes 5 seconds to run. It takes 5 seconds to run this operation. So this is artificially making, pretend we have and this should be a task int. Pretend we have to do a bunch of computation. All right, pretend we have to do a bunch of computation. Take us, I'm gonna slow it, 2 seconds, 2 seconds here. Takes 2 seconds to perform this task. All right, so if I wanted to do console.writeLine of perform action let's do 2.
This is the real voice saying good morning.
Good morning, this is the real voice. Welcome to the stream. Happy to have you here on this beautiful Tuesday. This is going to take a lot of time to run. In fact, it'll take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 operations run. So let's do a .NET run.
You in the back. Pay attention.
Hang on. I'm a liar. I'm a liar. We need to put in a wait on each one of these. I'm going to say wait for them to finish. Wait for them to finish. All right. So performing this, it's going to take 2 seconds every time we do it. 2 seconds every time we do it. Okay. What we can do though is we can create what's a table. We can create a table here, and I'm going to use a dictionary. I'm going to say dictionary of int. This is our inputs to int. So this is our cache here. This is our cache. And what we do is we say if the cache dot contains x, then we return cache of x. Okay. Otherwise, curse tags, dictionary of curse tags cheats. We can make it an array. You can make it an array as well. But the reason I'm doing it as a dictionary, so here, let's do a string of x or something like that. Here, string of x, like that. It's fine. It's fine. It's curse tags. Okay. So if it has it, we do it. Otherwise, we calculate is x times x. And then before we do this, we actually store it. We say cache of x is equal to our calculated results. And then we return our cache of x. There's some optimizations here, but the first time, what are you yelling about? I don't understand. Done something weird thing. I feel like this here. Use of unassigned local variable cache. Oh. Put this up here. I have to have the cache before I perform the action. It makes sense. All right, let's run it. The first time will take 2 seconds. The next times, every time after, it finds it very, very quickly. So as we go, so when we get to this 3, it'll take a little bit of time. But what we could do is later on let's do a 4, and then we do here, watch. We'll do 1, 2, 3. 1, 1, 2, 2, 3, 3, 3. I think you'll hopefully get the idea here. Always doing stuff after you write. So after I've stored it in the cache, I never have to do this operation again. So you can imagine this is an expensive operation. It takes 2 seconds to run. Maybe we have to call out to a file, read a file, do something like that. 1, 2, 2. So it still has to do the calculation once, but if you cache that value, you're good to go. You're good to go. So what I'm gonna do, so this is cache, this is memoization in a nutshell, where we have a cache, we save it, and we look it up. We can do another extra little trick here, and I'll show you how to do that over here. So that's memoization in a nutshell. Memoization in a nutshell. If you have any questions, let me know. Imagine the recursion creating a tree. That tree has a lot of subtrees in the same input, so we can replace all those subtrees with a value that was retrieved from another subtree with the same input. Exactly. And we know we're gonna have a bunch of the same inputs each time we do it. This is where I think if you did dynamic programming, you'd start at the right side and you build it up from the right to left. What's gonna happen here is we know that, let's say we know how many different permutations we have for just this chunk here. We've done it. When we get to this question mark, we can just say, okay, well, I know how many I need, and I can just add 1 to that if necessary. And so what I'm going to do, I have this underscore process springs here. This is going to be my base function. This one calls back into this memoized one. So we're gonna have a dictionary here. I'm gonna put it on the outside. We'll have we're gonna have a cache on the a triple of these things. So I'm gonna create a dictionary, private static dictionary. Our key is this thing, and our output is a long. And this is gonna be a new, missing a thing here, like this. All right, then we'll call this our cache, like this. Requires a second. Oh, I have an extra paren. There we go. Sick to the bone. You know, I was sick to the bone, and then you came into my life, and then it helped me not be sick to the bone no more. Sick to the bone. Thank you so much for the follow. Happy to have you here. IDNT, welcome back. Welcome back. Kavadra says public, private, protector are all just syntactic sugar for the compiler. Essentially, yeah. If I did read only, the compiler might be able to do some optimizations on it. I don't think for a dictionary, it's not going to. But yeah, it's syntactic sugar for the compiler to protect you from doing silly things. Reflection is pretty slow as the other thing, because you have to examine the bytecodes. I don't remember exactly what it is. You have to do some examination of the bytecodes if you're using reflection. I've never implemented reflection, so I don't quite understand it under the hood, but I've used it. But yeah, I've never implemented it. Okay, so now we have our cache. When we call process springs, we're gonna say cache dot if cache dot try get value springs broken and remaining, and then we have an out there that says out long results return results. So we're gonna say if we have seen this before, we just return the result. Otherwise, we have to do the calculation. We do cache of springs broken remaining is going to be equal to process springs of springs broken remaining. And then we were going to can I do long result? Can I do something silly like this? I can't. Okay. Let me do long result is equal to this. What? Oh, I already have a solution. Solution is equal to solution, and then we return solution. All right. I used a bunch of extra. I used a bunch of stream repel from as powerful as Miss Captain's receding hairline. And true. Look at this thing go. Look at this thing go. It's a nuisance. It's a nuisance. It's not too bad yet. We're gonna get some Rogaine though. Maybe Rogaine, you wanna sponsor the captain? If you do not try it, you can assign the results to the output variable. If you use not try get value, you can assign the result to the output and add that to the cache. You're suggesting I do this. So if it's not in there, you're suggesting I do this, where then I will do that. You're suggesting this? I'm gonna go back to what I had. I liked what I had better. I like putting this thing up here saying I'm gonna just stop. I like the pattern of if I have it stop, otherwise calculate it and go. This is just my personal preference. It's my personal. Only you take a troll's comment, turn it into something actually funny. Mendoza. We know we have a look. I know I have a receding hairline. Like I do my best. Mendoza, welcome back to the stream. Good morning, my friend. I hope you're having a beautiful day. You're just gonna pro game, didn't do anything. Look, maybe get Norelco or Philip, or Philip's Norelco are the same thing. Maybe get Norelco to sponsor you, JD. Keep that head nice and smooth, and get some polish. Maybe there's like a head polish company that will sponsor you. I'm gonna go with this one here. So I believe, let's make sure we didn't break anything. Let's make sure all these still pass. All right, so they still pass. They still pass. Let's try to test here. Anonymous, if you're referring, so one compression technique that is used. So if you want, do you want lossless or non-lossless? So JPEG is a format where you can compress images down incredibly small, but you lose a little bit of information, but the human eye doesn't care. And then PNG is a really good graphics format that is lossless. You can convert it down pretty small, not as small as JPEG, but you don't lose any information. And it uses some combination of like Huffman encoding. Huffman encoding is something I'd look at for compression. Mono, low 3K, mono, low 3K, mono, low. Thank you for following me today. We've got mono, low. Welcome to the stream, my friend. Thank you for following. Thank you today. I hope you enjoy your stay. Oh, Monolo 3K. Welcome to the stream. This is the real voice, hugely. I missed the first 400 or 500 followers at one point. Chappie. Oh, Chappie. Thank you for following me today. We've got Chappie. Oh, Chappie. Welcome to the family. I'd like to say welcome aboard. Welcome to the crew, and I hope you like your stay. Oh, Chappie. Thank you for following me. This is the real voice. Unfortunately, you can't sub here. You'll notice there's no sub button. There's no sub button. I'm not an affiliate. No subs. No subs. No affiliate. No subs. You can if you really want to. If you really want to, over on the Ko-fi, since you asked so nicely, we do have a Ko-fi where you can become a member. You can become a member and gain a few little things. The most important of is you get to create a custom command on the channel. You and I will work together to create a custom command on the channel if you are a supporter. And if you want, we'll create a custom video command on the channel if you're part of the bridge crew. Exactly, JD. Exactly, JD. Get a custom command. If you're desperate. Yeah, you get a custom video clip if you want as well. So if you want to sub, you can do so on the Ko-fi. Look, folks, Captain Coder's doing just fine. I'm streaming because I love to stream. You don't have to. Look, there are better places to spend your money than on this guy. But I appreciate it nonetheless. So if you feel you must, feel free to support on the Ko-fi. All right. So I think we're really close here. We got to do our day 2 or part 2. Public static long part 2 string inputs, and this one is just return input dot split. So I'm doing input dot split. It's essentially this, but there's one step in the middle. We got to do a select expand input. All right. So format. All right. Lambo we need a Lambo. Yeah. Hang on. Maybe we could add it. We could add Lambo where you need how many points for a Lambo? What do you guys think? How many points for a Lambo? I'm too few points. Just published a new YouTube short ranting about ChatGPT. Ooh, nice. Post it on the Discord, JD. Three points for a Lambo. Mooniz keeps trying to redeem my house. All right, so essentially we expand it for part 2. We expand the input, and then we test it here. So let's check fact. Part 2. How do you earn points? Great question. Give me a second here. I gotta finish here. You get points just for existing in the stream. If you're here, you get points. Does it explain points? I feel like there's something that explains it somewhere. Jeez, that's a few dollars, Nick. That's a few dollars there. All right, so we should get this in our sample input. Our sample input should be this, part 2, and our, just so I don't mess this up, I'm gonna run this in the terminal first just to make sure we don't have an infinite recursion. Let's exit here. As many as it takes to get a buffer overflow, I'm a little worried. I don't think we'll get a buffer overflow. .NET test here. All right. We should, if everything went well, we get one fail. We get one fail. We have one fail, folks. We have one fail here. And I believe this is our solution. I believe this is our solution to part 2. Boom! Boom! We done did it on this day. We done did it on this day. We got our star today. One fail, it must be me, JD. So, look, self-deprecating JD. Look, JD does self-deprecation is not the version of you I like. It's not the version of you I like. I prefer a happy, self-appreciating JD. All right, so we got ourselves a star. Let's do a commit. Get status. Get add. Get commit -m feat implement day 12 part 2. I really should put some more comments in there. All right, folks, we got this is the real voice.
This is the real voice, and you got me loving you. Oh yeah, we've got this is the real voice, following the captain's crew. You know I've got this is the real voice. I'd like to say thank you so much. This is the real voice. Thank you for the follow, my friend. Happy to have you here on this beautiful day. Thank you for being here to witness this momentous occasion. 250 points to all you beautiful people. We done did it. We got part 2 done. If you want to submit your solutions, we got a little bit more time today. If you want to submit your solutions, we can take a look at them. Exclamation point Q to queue them up. We got a few already. If you got other questions, feel free to queue them up as well. Nineberry. We're gonna start with Nineberry here. What happened when this is what happened when I tried to Butte Forest Day 12 Part 2. Oh, I'm looking forward to these. Just Part 1. That's okay. All right, we're gonna take a look at Nineberry's solution here. Let's load it in. Nineberry, thank you. We've got Nineberry. Oh, this is the real voice. Or someone asked, how do you get points? You get 9 points. Let's see here. What do I have it set up? In our Firebot. Folks. You can see how the sausage is made. Look at this sausage. There's a bug going on. They did an update. Normally it tells me who followed, but we're missing here. Make my code better. To make your code. I thought you were just, Nick, I just saw make my code better. I was like, I'll try. Ooh, there's a lot of people here. Thank you guys for being here. I love you guys. Okay. Currency. We have something called points here. And the way the points work, if you want to know how the sausage made, every 5 minutes, you get 9 points. And if you've chatted in those 5 minutes, you get an additional 9 points. You're welcome, Clayman. We're not going anywhere. I'm still here. If you got to run, Clayman, that's okay. Folks, also, do you guys know Clayman? Clayman Dev? Clayman. He helps us. He's defender of the earth, fights those moon people, folks. You gotta go check him out, making epic hero game. Attention all lurkers. Please give Clayman Dev your love. He deserves to be loved just like anyone else.
Check out Epic Hero Game. He's a Twitch streamer, streams development of this game, Epic Hero Game, which is going to be an epic game, a physics-based roguelike game where you build your own hero, combine your powers, defeat enemies. Be sure to go check him out, and then click that little wishlist button. Give him some love. Give him some love. But let's take a look here. Playman, I love you, my friend. I love you. But that's how the sausage is made, and then I award points randomly for a variety of different things. That's essentially how the points work. I did not make Firebot. Firebot is not all-in-one Twitch bot here. And this is a link to Firebot, which I imagine if I get too popular, Firebot's going to stop working, and we'll have to figure something else out. But we're not too popular yet. Okay, we were going to look at 9berry. My solution in C#. Let's take a look. Let's take a look here. 9 berries, better than 8. 9 berries, better than 8. We got 9 berries, better than 8. Let's take a look here. We'll put it in C# mode. C# format. Cool. I don't want to modify or copy data while recursing, so I use positions into the input instead of modifying the inputs. I wanted to. We'll take a look. We'll take a look. I feel like mine isn't the best. I specifically wanted. We got some stuff to look at. This one, I don't know if anyone's gonna be able to write a particularly beautiful version of this solution of this problem. Process line. Whether or not we unfold it. Okay. We do. Okay. So you do a parse and count. Parse and count. So you're doing a recursive solution as well. Do I use cloud services such as Amazon? Yeah, I use Amazon and Azure. AWS and Azure are the two that I'm familiar with. I used Google Cloud Engine quite a long time ago. Spurra, let's check it out. Feel free to drop it in. We got a few people in the queue ahead. We got people in the queue ahead of you to check it out, but feel free to drop it in. We'll take a look. We'll take a look. And if anyone else wants to ask any other types of weird questions, feel free to drop it in. I like the weird questions. I like the weird questions. Okay. So always end out of group to make state machine easier. So you've done something, always end out of group to make state machine easier. Okay. If we're unfolding it, we do it, we unfold it. Otherwise we just, this is a clever little thing you've done here. Tabs or spaces. Whatever my team's using. It depends. Anonymously, those two, it really depends. It depends on what you're doing. Each one has pricings for different things. I have found AWS to be cheaper in general. Yeah. But they're Azure, it depends on what you're doing. It really depends on what you're doing because there's like 10,000 different services. All right, so let's take a look at this. Is the parse and count. Parse and count here. These inputs are wild. Input, int. This looks like something I would write. All right, so you have current group length, current or next group position. You have a cache. I don't quite understand the cache here. It's our current position, current node group, current thing, damaged group lengths. Oh, you've done something really cool here. I like this. I like this. You don't look at the string. You've done something to where you convert it into a damaged group links here. I want to look at this because you can essentially ignore all of the dots in between. All you need to know is that there was at least one dot in between, right? And then we know our damaged group thinks. I really like this. I really like this solution. I think this is much better than mine. That's not what you're doing, 9berry? Damage group links? Hang on, input position. What are we? All right, let me keep looking then. Is input static somewhere? Where's our input? Oh, all right, sorry. I missed our input. I was like, you don't even have a string coming in here. You just have some magic thing going on where you've combined your group somehow. Okay. All right, I missed the input. It was up here on this line. And I was going like, you've done something crazy cool here that I'm going to look here. You've done magic, yeah. All right, sorry, I missed the input up here. There it is. There it is. Okay. I'm wrong.
I'm wrong. Folks, it's okay. It's okay. Forgive me. Please forgive me. Nineberry, I'm so sorry. Please tell me it's going to be okay. Nineberry, do you forgive me? Do you forgive me for misreading, misunderstanding, and misrepresenting you? I'm sorry. Spura83, welcome to the stream. Happy to have you here. It's all okay. It's going to be okay. Thank you. Thank you. All right. So same thing here. If we're cached, if we've seen this before, we're done, and we just return it here. I like what you've done here. You have a pointer. You have a pointer where you're looking at it rather than, this is where my Haskelling, this is where my Haskell and functional program, like, oh, we just treat this as a linked list. We pull things off. We put things back on. This is a nice way to do it so you don't have to rebuild these strings. So the number of strings I'm building is kind of insane when you really get down to it. Okay. But I like it. All right. So we're going to look at the token here. So we're going to pull off the element at the beginning here. So we need to find, if we're less than the length, we can get it. Otherwise, we are the empty character, which is basically a null terminator. Usually this is called like the null termination character. In C, we use this to denote when we're at the end of a string. Okay, so if we have a question mark, we do the result by processing. You do what I do here. So we handle, oh, you have a handle token. Handle token, which ends up parsing back here. So you say handle the token with a dot and handle a token with a hash. So find the both, and the number handle token must return this. So we're gonna do it once with the dot and once with the hash. That's what I do. Call it, yeah, perfect. Otherwise, we just handle the token with the first token there. And then at the end, we cache our result. The first is special hand for the question mark. Yeah. So this is where we have to do a split. We go left or we go right. This is where we have to do a split. Okay. And then in our handle token, we have our cases here. We do a switch case. All right. If our token is a dot, if our current group length is 0, parse and count, we move forward one position. And continue. All right, move forward one and continue. When we are in a intact outside damage group, just continue scanning. When we're in a valid closing group, when we're in an invalid closing group, we return 0. So this is the recursive part. We say nothing after this point can be valid because the damage group length is not proper. We don't have a valid proper group length. Otherwise, we look for the next group. So we recursively say, okay, come here. Our input position increases by 1. Our current group length goes down to 0 because we just finished a group because it was a dot. And then we sort of go through the next things here. So we recursively pass this stuff in. All right, so now we have the hash case. This problem's just gross all around. I don't know if I like your code better than mine or not. It certainly feels, I'm not a huge fan of switches usually, but it's not a big deal. Just reading this is just so painful to understand the logic of what it's doing. Like if you didn't know the puzzle, was, well, you'd be like, what the heck is this thing doing? Can you imagine looking at this and trying to infer what it's doing backwards? And that makes this hard to read. Cyan Streams, welcome back to the stream. Balint, how you doing, buddy? How did your fundraiser go last night? Were you able to reach your goal? How does the fundraiser? Cyan Streams is a streamer. They were doing cancer research fundraiser last night. I don't know, is the fundraiser continuing on? You hit 1K, congratulations on that. Folks, Science, be sure to give Science a follow. Incredible streamer, friend of the channel. Does all kinds of great stuff. Microscopy Monday. My favorite's Whack-em Wednesday where we do some drawing. What are you up to tonight? Science? Balint, what are you up to tonight? Continues next Monday. Awesome. Be sure to give them a follow. Be sure to help fund cancer research if you're able to. All right. Now we're going to do the case where we have the hash. If our current group length is not equal to 0, we need to check if we should continue scanning. if the current group length plus 1 is greater than the damaged group length. So if we're going to end up with too many hashes, we stop and say, hey, by the way, there's no valid solutions here. There's no valid solutions. Tinker Tuesday, we do models. Gotcha. Hi Nintendo, this has so much white space, it feels crowded than it would without the space. I'm not sure. Yeah, it's one of those things where how do you organize code is a challenge. It's a challenge. It's tricky. The length of this is rough on my eyes. A little rough on my eyes here, but that's okay. We're gonna parse and count. We can tell whether or not it's invalid here, and then we can parse and count here. We move our input. Our input position goes down 1. Our current group length increases by 1, but we have current or next. Current or next. What's current or next? Okay, we propagate that through. All right. If we were a hash and our current group length is 0, this means that we are starting a new group. So if we happen to be at the end of the grouping, if we're at the end of the grouping and there should be more things in it, it's an invalid solution. So we return 0. Return 0 here. Otherwise we continue parsing, looking for the end. We're starting a new group. Starting a new group here. So our group length here goes to 1. Now the question mark, we're saying this is not a possibility because we handled it here. So we should throw an exception. If we're at the end, our current group length is this, we added a dot to the end to make sure this doesn't happen. Is that true? Check there are no missing groups. And if there are no, if we didn't reach the end properly, we return 0. Otherwise, return 1. I'd be curious, Agg, let me know if I'm pronouncing it right. I can't remember. AJ, I haven't seen one yet. Is a C string? No, they have the Nineberry has constructed that into this. They've built it up. They've explicitly done this null terminating thing here to make it C-like. Okay. And we go through and we recursively go back and forth. We call this thing, we end up with our ones. Did you do, and then your memorizations here at the top. Whew. These are tough to read. Nineberry, thank you for sharing points. Add Nineberry, 500 points. This one's hard to grok your way through a little bit. If anyone has an iterative solution, I'd love to see it. I think you could do this iteratively using dynamic programming. I'm almost positive. Torn to Oblivion, thank you for the follow. Have you met Torn to Oblivion? They have followed me today. You know, Torn to Oblivion. I love you. Thank you so much for following me. Torn to Oblivion, thank you so much for the follow. Happy Tuesday. I hope you're having a beautiful day, my friend. Nineberry, thank you for sharing this with us. A great solution. We're going to look at a Rust solution here. We're going to look at a Rusty solution by Spoof. Spoof, let's check it out. You can also just create a stack and use that menu for implementing recursion. It's still a recursive solution at that point. In my mind, it's still a recursive solution if you use a stack. You're just explicitly using a stack. When you do it recursively, you're implicit. The stack is implied. Yeah. So we're going to pull this solution in here. We're going to go to Rust mode like this. This is Spoof solution points. Add Spoof. 500 points. Thank you for sharing your solution with us. We're going to look at this Rusty solution here. We got Sar Enigma. Sar or Sar? I'm going to go with Sar Enigma. Sar Enigma, thank you for following me. Sar Enigma, thank you for the follow, yes. Thank you for following, and I hope you enjoy your stay. Thank you for following, I'd like
to say thank you. Thank you for the follow. Found a streamer here on Twitch working on that code, but I can't find him anymore. Ooh, I'm sorry to hear that. Okay. Oh, hi, Tin. You're correct. You're correct that, you are correct that this isn't a tail call recursion. So if you had a bigger input, if our inputs were much longer, we could get a Stack Overflow. We get a Stack Overflow. That said, the number of recursions is the length of this. So we'd have to get pretty long. We'd have to have a pretty long input before we get a Stack Overflow. We do have the system call, so I don't know what the default is, but it'd have to be pretty long before you actually get a Stack Overflow. But yes, we could. Thank you for the compliment, Merc Desert. Happy to have you here, my friend. Welcome to the stream. Here we go. Here is our Rust solution by Spoof. Spoof, thank you so much for sharing your solution with us. Spring status working, broken, unknown. So you're gonna build up an enumerated type to be able to do stuff. When we parse it in, we build up a mapping from our bytes to these. Just makes it easier to read, I'm sure. And then we have our blocks here. We have our springs and our blocks. Our cache is here. Spoof says his runs in a few, like, not under one. You're trying to go under a millisecond. Spoof, if you're still here, let us know. I think Spoof's trying to do it under 1 millisecond. And so his solution, I think, is at 30 milliseconds is what he was saying. All right, so count arrangements. We look it up in our cache first. Then we have a function. Oh, this is get cache. This is set cache. And this is munch not working. I'm not quite sure what this is doing here. Set cache, munch not working is a function. This is saying, this is what we're gonna read off a not working spring here is what I believe this is saying. So if it's unknown or broken or this is where we pull off the next element here. Black Desire TV, Black Desire, Black Desire TV has followed me, and I'd like to say thank you for following me. Black Desire, thank you so much for the follow. Welcome aboard. Welcome to the crew. And we also got TA2212, TA2212. Oh yeah, thank you. Oh TA, thank you for following me today. TA, thank you so much for the follow. Happy to have you here. Stack Overflow is a great forum for sure. For asking questions if you're stuck. I've used it a few times. Usually you don't have to ask questions. You can find someone who has had your solution anyway. Welcome to the stream, my friend. Happy to have you here. Hope you're having a beautiful day. And welcome to the Academy here. All right, so here's our recursion. Here's where the recursion actually happens. And so we're going on our springs, blocks, cache, and then our indent, which I'm not quite sure what that's gonna do just yet, but we'll get there. We'll get there. So we are going to, we have a working spring. This is the optimization I say we could do. We just pull off the working. If there's a dot, we can just keep going. We can just keep going, pull them off until we get to something that's not a dot. So we have a dot here. We're just gonna keep iterating down until we get to something that is not a dot. So the question marks or the hashes are the important part. If we are empty and there are no more blocks, then we have a valid solution. I'm assuming this is what that's doing. If it's empty, if we have no more springs to look at and we have no more blocks, we're happy. If we have no more blocks and we have no more broken things, we are also happy. So this means that we have a valid input, Okay. There's not that many dots in the full input, yeah. So some count, we're gonna get, so now we're gonna look up in our cache, and we're gonna say if something's in our cache, then we return that count. We've seen this problem before, so we're done. Okay. Otherwise, these are the things that we have to do. if there's some great optimizations here too. Say basically saying if the length of our springs is less than the size of the blocks minus 1. If there are not enough springs to cover the blocks, there are no arrangements. So we finish this arrangement here and we assign it the value of 0. So this saying that invalid, there's too much stuff left in our inputs to actually make this work, so not possible to finish it. Otherwise, the first spring is unknown, then we can either assume to go working or broken, so we try both cases. All right, so we count the working cases and we count the broken cases here. So this is our recursive call. And then we do a munch here. We munch out the first spring, munch not working. And then we recursively call this here. If it was munchable, we perform the recursive call. If it wasn't munchable, we have a none here. And then at the end of this, we set the cache to the sum of those two things, the left and the right side. The sum of if it's working and if it's broken. Now it must be that the spring here is broken. All right. So if this is saying if it was unknown, we have to do two cases. If it's broken, we have a little bit to do here, where we're going to go ahead and do munch not working, which was the function we defined, and we say go ahead and munch it. And if it was munchable, if we were able to munch it, get the recursive value, and we're going to store that. Otherwise, it's 0. So if it wasn't munchable, if we couldn't process it, we get 0. And then we're going to set the cache here. And at the end of the day, we just return the lookup. We recursively call springs. We've defined all of our functions. We actually just call this thing here. Part 1 is calling it and then summing up all of the arrangements. Part 2 is essentially how we're going to expand it out in our Rust solution, and then with the same solution. Woo! Rusty, like it. Nice solution here. Thank you for sharing. Let's go check out the next one. We got 30 more minutes. To check out the next one. Let's close to I'm going to put my solution over here. We're going to close everything to the right. Hex tree. We're looking at hex tree solution. I'm assuming it's going to be in Python. Been doing in Python? Yes, Python solution here. Hex tree for submission points. Add hex tree. Hex tree. There we go. 500. Curious what you think of my curse code. We'll get there, Nick. We'll get to the curse soon. Double then, add a quarter. Sorry, folks, if you really want me to see something, feel free to tag me. Just because my eyes, since it's a little bit hard for me to do a little bit of code review and read the chat at the same time. So feel free to tag me to try and draw my attention at it. If you do at Captain Coder, it changes the color a little bit. So a little bit easier for me to see if you do that. So I know there's a lot of chit chat going on between people, which makes it a little bit difficult to follow as well. Oh, or use exclamation point Q to get your question in. Exclamation point Q will guarantee I said I'll get it in here. It doesn't have to be your code. All right. Number of arrangements takes in a record and a pattern. I'm assuming record is going to be our lookup. Let's look at what you call record here. Number of arrangements L1, R1. Oh, this is our line. This is the line that we're going to do here. You did a dynamic programming with memoization. Okay. Num array here. Okay, so our table gets built up here. So we're doing memoization. It's not an iterative approach. It's a recursive approach, which is fine. Totally fine. This is what everyone's done so far. If we have it in our table, we return it. I equals 0, j equals 0. Then if we have this is hard for me to read. I and j, I wish were named something else. Because it's hard for me to understand what I and j are here. I'm assuming if it's 0 and 0, we return 1. This must be what's left. Both are empty, I'm guessing. Yeah. If both are empty, we return 1. If I is empty, if they're not both empty, I here is our record, I think. So this is saying if we have springs left but there's stuff left in our pattern that's not valid, so we have to return 0. If J here, comment on line 5, where we restrict the first I characters and first J nums. Okay, we restrict the first I characters and first J nums. Gotcha. Thank you, Hextree, for explaining it to me. So my comment on this, and there's plenty of people write that this is how a lot of people write code. These are not very descriptive of what the data is. This would be one criticism I'd have. But this is competitive programming. It's competitive programming. You want to save those keystrokes. Naming is the hardest thing in the world, my friends. Naming variables. Programming's easy. Naming variables is hard. It's hard for me to I'm not smart enough. All right, so now in the case where J, this is the number. So now I have to there's a cognitive overload. What is J? J is first J nums. All right, so if we have none of those, and we have all hashes, we look at all the characters left in our record. If there's only a hash, all are not equal to hash. So we're looking for if there are still things that are broken. So if we have no broken things left, but we find broken things, this will be false. Or it'll be an int that is false. This is, oh, I hate, so hate is such a strong word. You're taking advantage of the fact, all right, so in Python, apparently, int true, and this, in C, this other thing, int true and int false gives us a 1 or a 0. And so this is like information you have to know that, hey, I can convert this to a 1 or a 0. That's fine. It's fine. It makes the code more concise, but I think it makes the code slightly harder to read. That's just my opinion, though. That's just like my opinion. All right. And that's totally fine. Now we're going to say if all languages don't do that. All languages don't convert true to to a 1 and false to a 0. I don't think that's true for all languages. But many. For many languages it is. All right. So results here. This is our recursive call. C# doesn't. C# you can't convert an int. Maybe I'm wrong. Can we? Now I gotta try it. Is there a C# interpreter? How do I pull up the C# interpreter? C# interpreter terminal. C# interpreter. C# interpreter command line. Hextree. Sorry. I got. We'll come back to that. I got distracted. We gotta focus. This is our recursive call. If the thing I-1 in our record I-1, where we restrict the first I characters here, we're looking at a character seeing if it is a dot. So for a dot here, that means we're at the end of a group. So this is us finding the end of a group here and then doing the recursive call. Otherwise, we need to know what the number is in our J-1. I'm assuming this is the number of errors in this particular group. And if it's greater than, if num is greater than I, if num is greater than the number of errors in here, this can't possibly be valid, so we result is 0. Or if the number of dots here, we need to find dots in it, and if we find a dot and we only have, and we need errors left, we still return 0. Yeah. This is the number here. This is like essentially where we're detecting if we have enough, if there are still errors left, and we're looking for those errors. You're short-circuiting, saying let's get down to 0. So you have the optimizations as mentioned in mine. I don't do any optimizations in mine to say like we can skip a bunch of stuff. You are skipping a bunch of stuff, potentially skipping a bunch of stuff here, which is great. Okay. Otherwise, we look for another invalid situation. It says, hey, if we have stuff left to compute, but there is if we have more, if it's greater than num and we have a broken thing here. So this is detecting, I'm not entirely sure exactly how it's doing it, but this is detecting if we have too many, it's either detecting if we have too many or not enough errors. If so, it's checking for an invalid input. Otherwise, we have a potentially valid input, and we need to go into recurse here. Too many errors, yeah. Okay, so taking too many errors. One or the other. I like the variables aren't helping. In my brain, the variables aren't helping out. I'm not smart enough. To do it here. And then finally down here we say if there's a question mark. There's a question mark. We're gonna do the result plus the number of rays, I-1 here. So this kind of does, somehow is doing both cases, and I don't quite understand it. I-1 here is coming in. These are where these optimizations would be good in our program. In my program, to do optimizations, I needed to have the basic one so I could actually debug it, because I did end up with a bug in there. We have a recursive case here, and then we add it to our table and return the result. Really solid set of if-elses here. There are question marks, we add in the result that we had at the end of the string. If there's a question mark, we add in the result that we had at the end of the string, and we reduce the group by 1 here, because we're going to the next thing here. And then we just say, here's the length of our record, here's the length of our pattern. Yeah, at the end of the string, end of the string case. Gotcha. I see. Very cool. And then Python has some cool stuff. This is cool for part 2, where we can just take like our inputs and say multiply it 5 times. We can't do it here because we have to join with a start, but our input here we can actually just multiply 5 times, which is kind of cool. Python lets you multiply strings, which I think is cool. So in Python, we can do AB times 5 to have it repeat, and which is, I think, really cool. I like it. There we go. Nice little thing here. And then we just add the arrangements. We have it memoized. Nice. What's your schedule like for 8-week sessions? I work with you, Raycat Hudat. I will work with you. So Raycat, you're referring to the lessons. Is that correct? Essentially, we usually do one class. We'll usually do one class a week, and I will give you homework depending on what you want to do, of course. So for lessons here, folks, anyone who wants to take lessons with the Captain Coder, you can. Or if you know someone that wants to take lessons with the Captain Coder, you can sign up. I do 2 types of lessons. I do one-off lessons. These are usually 60 to 90 minutes, depending on what you need. Here. Up to 6 people. So if you have, like, say you're taking a class, you can come in here with lots of people. Right now, there's no wait list. If I get too full, I'll put a wait list. There's no wait list right now. When you sign up for this, we will work out the details of how it'll be. Usually, it's one class a week for whatever topic you're working on. Usually, you'll want to send me a message on Discord first to talk about what you want to do, but you can do it here. And also, really, so I've done 4 of these. I'm actually in the middle of doing some of these. I've finished 1. I'm doing 3 more still. But usually it's 8 weeks long. We do a custom course for you. So you say, hey, I want to learn C#. Hey, I want to learn about AWS. Hey, I want to learn about Docker. And say, okay, here's the type of program. What is the time constraint for you? Can you do 2 hours of homework a week? Can you do 5 hours of homework a week? How much homework can you do per week? And we'll figure it out from there. Spoof. I just watched VOD of yours at my source. I missed it and then used independent variables just when I had to debug. Spoof, I really liked your solution. Hextree, I love this solution. The really straightforward, pretty straight to read, and you've iterated through the cases in a really nice way here. I think this is a really beautiful solution that doesn't have the gnarly grossness that I have. So I look at my solution, I'm just like, oh, it's so gross. And I would love to go back and fix it potentially. Your solution feels beautiful to me. About as beautiful as a recursive solution could be. It's very tight, concise here. So thank you for sharing this with us, Hextree. Excellent, excellent solution. Bad cop. Oh, time for some pain, apparently. We're going to see how much bash I can handle here. Raycat Who Dat, I hope that answered your question. All right. We're gonna look at some madness here. We got a bash solution. Make sure we're in bash. Do we have sh? Oh, change language mode. Shell scripts. All right. I don't even know. Recursive hell. Okay. You have your record sizes. You have a cache that you're gonna use here. Okay. This is how we're doing input arguments into the descended into hell. Love it. Yeah. So if you're not familiar with bash, this is the like command line in Linux. Usually Linux, Mac, you have some kind of shell scripting line. Bash is a very common one. But man, these are our arguments to our functions here. And so saying the first argument, second argument, third argument, fourth argument, $0 would be the name of the function. Bad cop, you've ever heard of bash? That's right, bad cop. Have you ever heard of bash? All right. So if our iter is 0, this is just going to be too painful for me to read, I think. We have a counter that we increase here. So we're basically saying if our left is 0, this is our base case that says if we've reached the end of our input and there are no elements left to parse, so our 0, 0. If headache, give up. That's right, Nix. That's right, Nick. All right. Otherwise, our key. Oh, this is I was wondering how you're gonna do this. As well, ZSH for the win. Yeah. ZSH is another flavor of a shell. So our key here. I didn't quite know we could do this with in bash. Bad cop, are you still here? I didn't know we could index. We could just have hash maps or dictionaries in bash like this. That's cool. That's cool. So this here is saying if we are finding a cache hit, so we look up this cache hit. This is saying that it's not empty. An associative array. Cool. Nathaniel, I did not know that. Thank you for the information. Now I know. We are looking at your code, Bad Cop. I'm tearing my hair out here. Points at Bad Cop for tormenting us. So for submitting your code, 500 points. And then for writing it in bash, we got to give you like an extra 250 points because this is insane. This is hardcore mode. Yeah, PTSD. The PTSD. Post-traumatic bash syndrome. No assembly entries yet. Yeah, I haven't seen any. I wouldn't be able to grok the assembly entries, unfortunately, Proton. So we find our cache. Otherwise, our counter. Oh, so we increase our counter by the cached amount. Okay. Counter before. So we save our counter size here. And it's a spoof. If it speeds up because you cleared your cache, it has to do with how hash maps resize themselves when they get too full. Your previous entries, here's the thing, your previous rows likely don't have anything in common with the next row. And so as your cache gets bigger, it has to resize itself. It's amortized O of 1. It's not actually O of 1, it's amortized O of 1. So it's resizing. So I bet that makes sense to me why it'd be faster. Either that or your buckets are getting really big. It depends on how it's implemented under the hood. Okay. If our record's empty, we're done.
Oh, if our record, hang on, if our record is not empty. No, if our record is empty. This is Z saying it is empty. Okay, if our record is empty, we're done. The cost, like this is incredible that you've done it in Bash. We have an index here. Okay, we're gonna read through. If it's blank, then we continue. So we're gonna skip blank characters, I think is what we're doing here. We're reading through all of the characters in our inputs. We find what's left. We're doing some regular expression here. We're saying starting with, if we start with a hash and a question mark, this is our budget here. The remaining sizes put together. Gotcha. This is really cool. All right, so if our budget is less than the cost, we break. All right, is the branch a financial disaster? What a comment saying, look, there's no, we can't solve this. This is not possible, so we leave, right? It's just an iterative, oh no, we have the recursion in there. Otherwise, we do a slice here. We have our record index size here. We look at our slice and we say if our slice is less than our size, we also are done. This optimization 50% runtime, nice. Look at that cray there, that cray. Oh yeah, we got it. All right. So otherwise, we are gonna, if we have these dots, we skip. So we're just like, we have a dot, but let's keep going. This part here is where we have the financial disaster. All right, we're gonna do a grouping here where we start with question mark hash. If our group is, this is checking if we have not enough to satisfy the remaining hashes, right? It's actually just 10% faster. Oh, that's spoof. That's spoof saying that. We're gonna break here. Otherwise, our index, we go to the next spot and we continue. Let's take a peek here. Here's our descent into madness. If we are not a hash, does this mean we're a question mark? Does this mean we're a question mark here, bad comp? Because we bypassed all of these? Or does it specifically mean that we have a question mark or a dot? Our descendant here, we build up a string for our descendant based off of our indexing. It's looking ahead to see if it's a question mark or a dot. Okay. And then this is our function. We're going to descend with our recursive call here with all of our slicing and whatnot. And then if we hit obsidian, we're done with that. Otherwise, we increase our index, and then we feed our record into here. Okay, so IDX is getting increased. IDX lets us iterate down this thing inside of it. This is fantastic. Oh, it also finds the empty string. Gotcha. So this here is piping our record into this read loop. Beautiful, horrible. Insane. And then when we get down here, did we hit this means that we missed the cache. And the change, your variable names are hilarious. This is what was left over. We're gonna go ahead and toss that into our cache here. Whew. For part 2, this is funny. Oh my goodness. I love that. Just manually question mark. This is the easiest way to do it, actually. I love this. I'm surprised I didn't think of this. Not surprised. I wish I had thought of this. What a beautiful thing here. Max depth here. We're gonna loop, and we descend into madness again, and then we echo out the counter. This is good. I love this. Wish I thought this. And then this, don't fork bomb me, bro. That's funny. I gotta go fast. Does this
we're parallelizing it here. How did this speed it up? So you want 99.75% optimizations. So you're parallelizing it on your inputs. Is that what you're doing? It speeds it up by about 10x. That's amazing. That's amazing here. So you take each of your lines and you run them independently, and then you bring them back together. Is that how you do it? By using all of my cores. Bad Cop, thank you for sharing this with us. This is amazing. Super fun solution. I can't. So down to 20 milliseconds. Oh, you down to 20 milliseconds. Nice, Spoof. Nice. Very nice. Oh, what a fun solution. We gotta go fast. We're running out of time. High-tit tendon. Let's take a look here. Pull this up. Hang on. Pull this in here. This is another Rust solution. Let's close this one. Don't save that. Let's do a point. Add high-tit tendon. 500 points. Thank you so much for sharing your solution with us. And we're going to take a look here. Rust solution helper. This is sort of like, I'm assuming this is similar to my underscore thing. We have the string of our, I'm assuming this is going to be our remaining string. This is an array of our counts. So these are the remaining bombs that we have to find in the next group, or in the current group, or whatever it happens to be. This is our groups of bombs. Or I call them bombs, groups of broken springs. I'm calling the hashes bombs for some reason. And then this is our cache. So we pass our cache in here. Our cache goes from our string box size inputs like this, and then we get back the U64, which is our final result. If we're empty, we check to see, this is beautiful. I like this. If we're done looking at, if we have no more springs, if we have no more counts, we're done. If we have no more counts and we don't contain any more broken springs, we're happy. So this becomes a 1 or a 0, here. The overhead spoof, the overhead and starting up the multi-threading would be probably too expensive. Okay, so if we have a cache hit, so here we're saying if we have a cache hit, we return the result from the cache hit. Otherwise, we have some work to do. If we start with a dot or a question mark, if we start with a dot or a question mark, result is equal to our helper plus whatever is left over here, counts and cache. Oh, I see. You have it down here. I see. This is where so you're saying if it's a dot, treat it as a dot. Oh, I really like this. High-tit tendon, I really like this. You're just saying, okay, we're going to calculate our result here. Count all the possible solutions that if we're a dot or a question mark that we're going to treat as a dot here. I really like that solution a lot. I like this much better than what I did. That's great. Okay. Otherwise, it basically treats it as both. And then down here, because mine was like returning the recursive call, I couldn't do this. But you are summing up the results here, which is really nice. And so now in this one, we have treated as a hash. So if it is a hash or a question mark, treat it as a hash. And then we're going to go ahead and find the solution here, where this is making sure that technically it's possible for it to be the case that we do it. So if this isn't true, it means that our input, there's no valid input here to satisfy a bomb, which I like. And then we're going to call our helper. Otherwise, we call the helper and we add that to our sum. At the end, we know we haven't hit the cache, so we're going to add it to our cache and then return the result. I really like that. This is really clean. I like how clean this is. What a clean solution. In my mind, that's very clean. And then it's all about parsing and building these things up here. So we do the join 5. Oh man, high tendon. This is my favorite one so far. The Python solution was really good too, but I'm just, Rust is just, you know, look how, I find this beautiful. The Python solution was really nice too. Hex Tree, that was my second favorite. Really, really clean. High tendon, I gotta ask you, was this the recursion you wrote on the first try, or did you clean it up? I just gotta know, because this is impressive if you thought this all through from the get-go. You had to clean it up. Okay. Yeah, I wish I cleaned up mine sometimes, but like one and done, boom, ship it. You're not that good. Yeah, this is where you get so much better when you refactor. And it's something I should really be doing a bit more on these puzzles. I just wish I had more time. Nick, here we go. Brace for impact. I loved that solution. Just part one today. Just part one. Let's take a look. Nick, thank you for sharing here. We're going to pull this up. This is your Reddit submission here. I tend on. I love that solution. Refactoring and looking at what other people are doing is so good. I see this. Sorry, I just gotta admire this one more time, and really say that I want to refactor mine to be this good. All right. Generations. Okay, so you generate all of the permutations, Nick. You generate all of the permutations. Let me ask you, is that true? You take your input and you go through and you actually generate a list with all the permutations, and then you use that to calculate it? There's a gist. Okay. Can you send me the link to the gist? I don't see with code highlighting. Oh, it's in my queue list. Gotcha. Thank you. And I'll pull that into VS Code. It's just a little bit easier for me. I made it specially for you. I appreciate that. I'll close this. Paste it in. We'll turn on C# mode. Okay. All right, here's our input. Generate permutations. So this is result.add range, generate permutations, returning a list here. Otherwise, we add the result. Result.add range. So we do a recursive thing where we combine all of these lists together like this. So for each character, new variant here. So we're going to calculate the variant on it here. So I assume you're taking every question mark and you're doing it, and then you do a calculation to see which variants are valid. So you generate all of the permutations, and then we match the valid permutations. So you go through and you're going to find the groups, put them together, and then check that against the valid thing, and then you just filter them out, all the valid ones, and that's our solution. The problem with that is the number of permutations on the inputs just get massive later on. So that's going to be, and the second generator pre-validates with regular expression. Gotcha. Yeah, so like I said, if we look at, see the units go from 16K greater than 2. So what we got to look at here is in our input, the reason this isn't going to work on the second part, and I think I mentioned this before, is we have 2. Every question mark gets us 2 new ones. But that still is too much for part 2. Some cases, 2 to the power 64. Yeah, it's just rough. But this is a nice, what I'll say is this is a nice naive solution. And I think this would be a great approach. If I saw one of my students doing this, I'd be like, great work at seeing, okay, I know I need to do permutations here. So I'll get back to it. Nick, I'm looking forward to seeing your recursive solution for part 2 or your memoized version of it. The regex generator up here, yeah. This is your regex generator. Have not seen anybody else do that yet. Gotcha. Where you're basically finding the number of occurrences that you're building out here. Use U64 or I60 for AOC. Yeah. All right, Nick. Still shorter than my solution. Is it? Hang on. Yep, still shorter than my solution. Nice work. Thank you for sharing, Nick. Let me give you some points. Add Nick 500. What happened when I tried to parallelize process day 12 part 2 with brute force recursion? Let's take a look at this image here. Did you blow up? Did you blow up your system? Hang on, let me pull this over. Let me pull this in here. You just CPU 1,200% usage. 1,200% usage. That's a lot of usage you're getting in there. It was still running. This is look. If you want a cheap heater, or I guess a really expensive heater, this is the way to do it. Thank you for sharing that, Nick. Let's see that. That's not edited. That's hilarious. You're just like, let's see if we can brute force it. I don't think she'll make it. Captain. She ain't got enough power. There we go. Pretty much. All right. Let's see here. I got technically I'm out of time, but let's take a look. Spura, add this to the list. Let's take a look. Spura, we got one more. And hi Titanda, we might not see your day 7 solution again. I'm sorry. Let's take a look here at this solution. Pull this in here. This is what language is this? What language we got here? CLJ? Is this Clojure? I haven't seen Clojure in a while. Clojure. There we go. Nice. Clojure. A nice functional programming language with parentheses. If you like Scheme, if you like Lisp, you'll probably like Clojure. You'll probably like Clojure here. Slurp is how we read input from files. We'll take a look if I have time. We might have time. I have to get to work, unfortunately. Or fortunately, I have a job. Civenge. Oh, Civenge. Thank you for following me today. We got Civenge. Oh, Civenge. Welcome to the family. Civenge, thank you for the follow. Welcome aboard. Welcome to Captain Coder's Academy. Nice to have you here. All right. Let's take a look. It's fine if you can't understand it. It happens. Let's take a look here. We're going to parse our input. We're going to map things out. We're going to multiply the input here. This is where we build our input. We do the repeat here. On our input here, we're going to parse some numbers. We end up with an array going in here. And we're going to do a pattern matching here. Match a group of hash or question mark followed by the end of a string dot or question mark. And we have our pattern. We're doing a pattern match on count, I believe, at the end of the day. And then we're saying if our count is less than the first argument. What is %1 doing here? Square bracket of the parameter list of the function. Yeah, so this is our parameter list. We have pattern and count. Pattern and count coming in. Raycat Hudat, thank you for your help. I'm not sure what %1 is doing, but I think this is saying that it is looking at, I feel like this is indexing something. The implicit first argument here, because we have a hash here. I think it's the implicit first argument. Gotcha. So we want to do a reduction. So this is like a loop. We're aggregating this. Might be like Perl. I haven't written Clojure ever, but I've heard people have told me I would like it. I like Scheme. I've done a lot of coding in Scheme and Lisp and Emacs Lisp. Reduce is a fold or an aggregate here. So we're going to reduce here, and then we're going to reduce 0 pattern. Is this actually a function? It must be. 0 pattern. Does this mean to call more? Pat is pattern string as vec, counts it also vec. We have a memoized version of this here. Okay. So I like that we can just say memoize. You can do this with in Scheme too. You can write, you do meta programming in Scheme where we can do a memoization. It says, oh, if I have a memoize it, just remember what we have here. I'm having a little trouble grokking through it. It should be full del. That's what I was thinking. I just don't know what the function that we're calling is here. So we're doing reduce 0 pattern, but pattern is a list. I don't know the function. Oh, it's curried. I bet that's right. I bet you're correct. I bet it's curried. It's saying we're gonna do a reduce and I have to give it a function here. Equals count. This might be the function. I'm not sure. There's a forward arrow macro there. Ah, I see. I think I see. All right, so we're gonna do a switch here. So we're gonna match. If we're a dot, we continue. If we're a hash, we use group match here to determine what to do. There's a question mark. We have to do both options. And then at the end of the day, if we're nil, so here is the case at the top that I had in mind, where we say, if we are done, if we think we're done, if we've reached the end of our input, if we have no more broken things, we return 1, otherwise return 0. Otherwise, we have to actually check to say, hey, do we have any broken things left? If we have any broken things left, we return 0 or 1. So this is sort of our base case of this. This is a beautiful solution. This is why I love things like Haskell. This is why I love things like Scheme. You can write these really beautiful solutions here, and you can end up writing stuff like memoize. We could probably write an attribute in C# to memoize as well. But the meta programming just makes things really cool. Thank you for your solution, Spura83. Thank you so much. Points. Add Spura83, 500 points. A beautiful solution. I forgot the letter S here. Points. Oh, this was so much fun. This was so much fun here. I do have to get out of here, but we're going to take a real quick look at Hytendon here. This is day 7. We're going to see if we can take a look at this real quick. And then I got to go. A Rust solution. This was our poker solution here. So anyone who wants to see, I'm going to put a new one here. Rust. Here. Yeah, this looks a lot like my, I'm already noticing the pattern matching and stuff that we do here. So we have the different cards here. You're using a lowercase j for your joker. This is going to tell us the ranking order here. So you can say find the index of, I'm assuming, to get the rank order. And you make the lowercase j, which I'm going to do, I'm assuming you're going to do a string replace from j to lowercase j to do that here. And so this is going to let us do a quick lookup here to evaluate the ordering here. Get total winnings is nice here. I can see that our match here, you're going to do a grouping. So you're going to probably sort things and then group them so you know the sets of things together. If we have 5 cards, a group of 5 all at the beginning, this is the highest rank. This is our 4 of a kind. This is our full house. This is our 3 of a kind. This is our 2 pair. This is our pair. And then otherwise high card is garbage. So we go to 0. So we actually do a grouping here where we combine the like cards together. Okay. We combine the like cards together to give us our counts. And then it looks like you're doing a bit shift and combining that with our face value to put it into a single digit so we have the sort order. We sort them and then we come in and we say, okay, we know the order that they're ranked. We have our index here and the value that is our bid, and we build it up and we build that sum. Really nice solution. This just makes me want to do Rust. This makes me want to learn Rust and play with Rust more. Yeah. High Tendon, I really like this solution. It's beautiful. And then for our get total winnings with Joker, you're just going to do a substitute with the J in here. So big J becomes little j. And then you're going to find your groups again. This time, you find your biggest group, and then you're going to say that this J is just going to become the letter that is the biggest group. And then I'm assuming that's what's happening here. Find the biggest group, this J, you're going to add that into that biggest group, and then you end up pulling out this same ranking here. And then you can do the same thing. So the J, the Joker here, gets added to the largest group. Is that what you're doing? Yeah. Really nice solution, straightforward solution, but beautifully done using maps and higher order functions. I love it. For sharing points, and High Tendon for sharing 500 more points for your day 7 solution. All right, folks, I gotta go. I gotta turn into a pumpkin. I gotta go teach. I shall be back tomorrow. I'll be back tomorrow. Let's find someone to raid. Let's see if anyone's doing Advent of Code here. See if anyone's doing Advent of Code. Geez. Advent of Code. All right. Coder 2K. Let's see if this is in English. All right, so I'm searching for people doing Advent of Code. We got Coder 2K. Send you a DM about it. Yeah, send me a cat, Ray Cat. Yes, it looks like we're doing day 12. We just started. We're gonna give Coder 2K a raid, folks. Keep that Advent of Code going, folks. Thank you guys so much for joining me. As always, he's speaking English. He's speaking English. I'm listening to him right now. He's in English right now. Oh, I think he's just reading the problem in English right now. Okay, so this is a German. All right, we're going to unraid. Sorry. Thank you, Nineberry. He's in German. Thank you for that. Advent of Code. Everyone, no one's in English. Software game. Advent of Code in Lua. Yeah, I saw that. He did his stream yesterday. Yeah, he's in German. He's just reading the puzzle in English. All right. We kind of don't have anyone doing Advent of Code right now in English. So we're gonna go raid C#. All right. Do you guys want game dev or C#? Game dev or C#? Jackie does code. Jackie codes does game dev. C# Fritz does some good stuff. We raided C# Fritz earlier this week. We're gonna raid Jackie codes. Jackie codes does Godot game development. Raid. Unless anyone has some suggestions. If you have some suggestions, I'd be happy to happy to go look at it. We're gonna raid Jackie codes, folks. Friend of the stream, great streamer. We love Jackie. All right, folks, have a beautiful day. Remember to keep coding, keep growing, be the best you can be. You're welcome back anytime, and we'll be back tomorrow for day. 13. Bye bye.